Hi all, welcome to goclasses. In this lecture, we will discuss K-map, all GATE computer science PYQs. This is part 4 of K-map gatecse PYQs. The previous parts you can find on the YouTube. You can search on YouTube K-map goclasses. Okay, on YouTube just search K-map goclasses and you will find all the part. You can see K-map all gatecse PYQs part 1, part 2, part 3. All the previous parts you will find on the YouTube. Okay, so let's start. Let's solve GATE 2024 question. Consider a Boolean expression given by f x y z, and this sum of minterms expression is given to you. Which of the following statement is or are correct? This is MSQ question, means one or more options can be correct. Here in the options, you can see they are asking the product of max term expression. Here they are asking this sum of product expression, and they are asking fxyz, is this independent of input y, input x? So this is the question. Let's solve. Let's see option A. In option A, the question is asking the product of max term expression, and sum of minterms expression is given to you for function f. We already know that for any function f, if sum of minterms expression is given to us, this is sum of minterms expression, and let's assume this is the minterm list S. Then how to convert this sum of minterms expression to product of maxterm? Means for the same function f, how to find the product of maxterm expression? Very simple. This sigma we will make pi, and we will write those indexes, those row numbers or those input combinations which are not in S. Okay, so I can say that this list also we can complement. Okay, very simple. I hope you understood. Because remember, for these indexes or for these row numbers, for these input combinations, function value is 1. And when we write product of maxterm expression, then we want those tuples, those rows, those input combinations where function value is 0. Okay, so for these input combinations, function value is 1. So for the remaining combinations, function value will be 0. Okay, so very simple. This is how we can write the product of maxterm expression for any function f if sum of minterms expression is given to you. Similarly, if product of maxterm expression is given to you, then we can easily write sum of minterm expression. So this is the simple idea, that you just exchange this sigma with pi or pi with sigma, and you just complement this list. Okay, here this is the minterm list, this is the maxterm list. Very simple. Okay, so let's see this option A. For this function f, which is over three variables x, y, z, and this you can see the order of variables is given to you. X is most significant variable and z is least significant variable. This is the order of variables, and by default also the order of variables, that is always alphabetical order, where x is most significant and z is least significant. Here you can see this sum of minterms expression is given to you. Then how to find the product of maxterm expression for f? Very simple. That will be pi, and we will write those indexes which are not here. So you can see here we have 3, 5, 6, 7. So basically product of maxterm expression will be 1, 0, 1, 2, 4. Okay, 0, 1, 2, 4. So option A, that is definitely correct. The question is asking for correct option, so option A is definitely correct. Now let's see option B. For option B, C, D, we need to find what is the minimized, or I can say minimal sum of product expression, because you can see in option B it is sum of product expression. Okay, so for option B, C, D, let's find the minimal SOP expression. For that, we will make the K map. Okay, so here the function f x, y, z, this is given to you. That is sum of minterms, and the minterms are 3, 5, 6, 7. So let's find the minimal SOP expression for f. For that, we will make the K map. So three variable K map I will make. Here, let me put this xy on the column and this z on the row. So 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Now let's fill this K map here. You can see 3, 5, 6, 7. These are the input combinations where the function value is 1. Okay. Here remember one thing, that when we write these xy, means the most significant variables, when we write on column, and this least significant variable when we write on row, then what is the numbering of these cells? So that is very simple. That is like 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let's fill this k map now. You can see for these input combinations, the function value is 1, 3, 5, 6, 7. 3, 5, 6, 7. Here the function value is 1. And in the remaining cells, the empty cells have function value 0. Okay, now let's label this k map with the area. You can see in these two columns, this variable x is 1, so this is the area of x. And you can see in the middle two columns the variable y is 1, so this is the area of y. And this is the area of z, because in the second row the variable z is 1. Okay, so you can see here, this is the area of z, this is the area of z bar, this is the area of x, this is the area of x bar, and this is the area of y. And you can see this first and last column, that is the area of y bar. Okay, very simple. Now let's find the minimal SOP expression. So for that, what we will do, we will make the groups of ones. Okay, we will make the groups covering ones. And remember, we will use minimum number of groups, and every group, every cube will be as large as possible. Okay, so here you can see, look at this one. From this one point of view, you can see this is a useless neighbor, this is a useless neighbor. Okay, the only useful neighbor is this. Okay, so we need to make this cube. This cube we will create. Okay, now let's see this one. From this one point of view also, you can see that this is a useless neighbor, because this cell is 0. This is a useless neighbor. Okay, so the only useful neighbor is this one. Okay, so let me make this cube also. Now what about this one? For this one also, you can see that this is a useless neighbor, this is a useless neighbor, because these are 0 cells. And the only useful neighbor, that is this one. So okay, so these are the 3 cubes. Okay, here now we can write the expression, the minimal SOP expression. For that, what we will do, we will write the product term for all these cubes that we have created covering ones. Okay, so you can see this cube, this is in the area of z and x. Okay, so I can say the product term will be xz. Next, you can see this pink cube, this is in the area of y comma z. Okay, so the product term will be yz. And this orange cube, you can see this is in the area of x comma y, so the product term will be xy. Now we can write what will be the minimal SOP expression. Minimal SOP expression, that will be xy or xz or yz. This will be the minimal SOP expression. Okay, so let's see the option B, xy or yz or xz. Yes, this option is also correct. Now you can see this is the minimal SOP expression, and in this minimal SOP expression we have variable x also, y also, z also. Okay, in the minimal SOP expression we have all these 3 variables. So I can say that this function f depends on all these 3 variables. Okay, so here I can say that function f is independent of input y. No, this actually depends on input y. You can see function f is independent of input x. No. Okay, so very simple. Remember one thing, that whenever the question asks you if some function is independent of some input or not, then for this type of checking, you just find the minimal expression, minimal SOP or minimal POS. You just find the minimal expression, and in that minimal expression you see which input variables are present. And if some input variable is not present in the minimal expression, then we will say that function is independent of that input variable which is not present in the minimal expression. Okay, is this clear? So remember, for option C comma D, for C comma D, remember, always find minimal expression. Always find minimal expression. You can find minimal SOP or minimal POS, that is your choice. Okay, of course finding minimal SOP is much easier because we are much familiar with finding minimal SOP, but you can find minimal POS also, that also we have seen in our lectures. Okay, so you can find minimal SOP or you can find minimal POS, but whenever the question asks you if some function is independent of some input variable or not, then in this type of situation just find the minimal expression, and then you see that minimal expression contains which input variables. Okay, that's it. So this is the complete analysis of GATE 2024 question. I hope you understood. Let's solve GATE 2025 question. Consider the following 4 variable Boolean function in sum of product form. So this function f over 4 Boolean variables is given to you. The sum of minterms expression is given to you. This is the minterm list. These are the row numbers, or I can say these are the input combinations where the function value is 1, where the value of the function is computed by considering b3, b2, b1, b0 as a 4-bit binary number, where b3 denotes the most significant bit and b0 denotes the least significant bit. Basically, b3 is the most significant variable and b0 is the least significant variable. Okay, so in this question, the order of variables is given to you. You can see here the order of variables is given to you, that b3 is most significant and b0 is least significant, and the same information is written also in the paragraph. Okay, you can see this paragraph. If you notice, this paragraph is basically saying that b3 is the most significant variable and b0 is the least significant variable. Okay, this complete paragraph, this paragraph till here, you will see the same information they have written, this same information they have written also here. Okay, now note that there are no don't care terms. Okay, basically in this function there is no input combination which is don't care. Okay, there are no don't care terms. Which one of the following options is the correct minimized boolean expression for f? This is MCQ question, so only one option is correct. The question is asking for minimized boolean expression. Tell me, is this asking for minimal SOP or minimal POS? With help of K-map, you can find minimal SOP or you can find minimal POS. Okay, this question is asking for minimized boolean expression. So tell me, this question is asking for minimal SOP or minimal POS? That is given in the options. From the options, you can see all the options are SOP expressions. Okay, if you notice all the options are basically SOP expressions. Because all the options are SOP expressions, it simply means the question is asking for minimal SOP. Okay, from the options and from this minimized expression, from these two words, or also from these options, basically I can say that this is what we can conclude, that the question is asking for minimal SOP. Okay, how to find minimal SOP expression for a function f? With help of K-map we will find, correct? Okay, so let's make a K-map. Here we need to make a K-map over 4 variables. Okay, 4 variable K-map let me create. So this function f is given to you, b3, b2, b1, b0. These are the input variables, and you can see this is the order of variables that is given in the question. b3 is the most significant, b0 is the least significant. Okay, and this function is given to you as sum of minterms expression. So you can see this is the minterm list: 0, 2, 4, 8, 2, 4, 8, 10, 11, 12. Okay, now let's make the 4 variable K map. This is our 4 variable K map. Okay, now in this 4 variable K map, let me put the most significant 2 variables on the column. Okay, this b3, b2, let me put on the columns, and let me put the least significant 2 variables on the row. Okay, so very simple. Here you can see 0, 0, 0, 1, 1, 1, 1, 0. Here also 0, 0, 0, 1, 1, 1, 1, 0. Okay, now let me label the areas also. So you can see that in these two columns, the variable b3 is 1. Okay, so this is the area for b3. Next, you can see in the middle two columns, the variable b2 is 1. So this is the area for b2. And in the last two rows, the variable b1 is 1. So this is the area for b1. And in the middle two rows, the variable b0 is 1. So this is the area for b0. Okay, now let's fill this K map. You can see I told you that when you put the most significant 2 variables on the column and the least significant 2 variables on the row, then what will be the cell numbering here? The cell numbering you already know, that will be basically 0, 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, this will be the cell numbering. Correct. Now let's fill this K map. You can see that for these cell numbers, the function value is 1. Okay. So you can see here the function value is 1. Here the function value is 1. Here the function value is 1. Then here function value 1. Then here function value 1. Then 11. Then 12. Okay. Now we have filled the K map. Now let's find the minimal SOP. To find the minimal SOP, we need to cover once. Okay. And to find minimal SOP, basically we need to make minimum number of cubes, every cube as large as possible, and every cube will cover only one cells. It will not cover any zero cells. Okay. Very simple. So here you can see, can I make a cube covering ones of size 8? No, I cannot make. Okay. Size 8 cube is not possible here. So the maximum size cube covering ones I can create, that will be size 4. Here you can see this will be a size 4 cube, correct? Okay. So you can see that this will be one of the cube, or I can say this is one of the prime implicant. What is a prime implicant? It is a cube covering ones which is as large as possible. So you can see this is as large as possible cube covering ones. Okay. Now remember these three ones are remaining, so we need to cover them also. And don't forget about the corner cube, the corner 4 size cube. You can see we have this corner 4 size cube also. Okay. So we got this corner 4 size cube also. Now only this one is remaining. Okay. I need to cover this one also. To cover this one, you can notice from this one point of view, you can notice that this is a useless neighbor. This is a useless neighbor. And this is a useless neighbor. So remember, from this one point of view, this cell number 11. So you can see from this one cell point of view, there are three useless neighbors, because all these three neighbors, they are basically 0. Okay. So there is only one useful neighbor, that is this cell number 10. Okay. So you can see this cube we will create. That's it. We have covered all the one cells. Yes or no? We have used minimum number of cubes. Every cube is as large as possible. So this is our minimal SOP expression. Okay. One thing you notice here, that these are the prime implicants that we have created. All these cubes, these are prime implicants, and every prime implicant here is EPI. Okay. Essential prime implicant. What is essential prime implicant? That is a prime implicant which will cover at least one cell uniquely. Okay. You can see that this this blue PI, this blue prime implicant will cover this one cell uniquely. You can see this corner PI will cover this one cell uniquely. And you can see this green PI will cover this one cell uniquely. Okay, correct. So I can say that here these three PI and all the PI, they are basically EPI. Is there any other PI? If they ask you for number of prime implicants, then do we have any other prime implicant here? Just check it. No, we do not have any other prime implicant. So remember, actually for this function, the extra information I am sharing with you, that the number of PI, that will be 3. And the number of EPI, that is also 3, because every PI is EPI here. And notice one thing, all the EPI, they are collectively covering all the one cells. So we will get unique minimal SOP, correct? Okay, yes or no? So here what will be the minimal SOP expression? Let's write the product term for all the PI that we got, all the cubes that we got. So you can see for this green cube, what will be the product term? This green cube, this is in the area of B3, B1, also in the area of B2 bar. Yes or no? So you can see this is in the area of B3, B2 bar, B1. Okay. What about the corner PI? This corner PI, what will be the product term? So this is in the area of B0 bar, B2 bar. Okay, B2 bar, B0 bar. And what about this blue PI? What will be the product term? This is in the area of B1 bar and B0 bar. Okay. So what will be the minimal SOP? You just do all of these product terms. Okay. Some of these product terms, that will be minimal SOP. So minimal SOP will be B3, B2 bar, B1, or B1 bar, B0 bar, or B2 bar, B0 bar. Okay. This will be your answer. So we have done the complete analysis of this question. We have found PI, number of EPI, okay, and all the EPI, they are collectively covering all the one cells. So we will get unique minimal SOP. So this is the minimal SOP. You can check the options B3, B2 bar, B1. B3, B2 bar, B1. B1 bar, B0 bar. B1 bar, B0 bar. And B2 bar, B0 bar. Okay. So option A will be correct answer. Actually, you can notice one thing here, that in all the other options, you have only two terms. Yes or no? Here you can see this is a term, this is a term. So you can see in all the remaining options you have two terms, but in the minimal SOP you have three terms. Okay, total we have three terms. This is a term, this is a term, this is a term. So three terms we have, and total how many literals we have? You can see total we have seven literals. Yes or no? 2 plus 2 plus 3. So total we have seven literals and two terms, and only option A has seven literals and three terms. Seven literals, three terms. So option A will be the correct answer. Okay. Let's solve GATE 2026 question. Consider a Boolean function f with the following min term expression. This function f over four variables PQRS is given to you. Sum of min terms expression is given. This is the min term list. Means these are the row numbers. These are the input combinations where function value is 1. Which of the following options is or are the minimal sum of product expression of f? The question is asking for minimal SOP expression, and this is MSQ question. One or more options can be correct. Now let's solve this question. Remember, when you will see this minimal SOP expression, then K-map will come to your mind. Yes or no? You will be thinking, let's apply the K-map. Okay. But the point is, this is MSQ question. And if the function has more than one minimal SOP expression, then of course you will have to find it. Okay. But here in this question, notice one thing very interesting. That is, in all the options you have four terms and equal number of literals. Notice this simple observation you just make. When you see this question and when you read this line, minimal SOP, immediately K-map will come to your mind. Immediately you will make the K-map for variable K-map you will make. You will fill the K-map, then you will start finding what are the minimal SOP expressions. Because remember, minimal SOP expression may not be unique. Okay, you for a function you can have one or more minimal SOP expression, and because this is MSQ question, so there can be more than one minimal SOP expression for function f. The point is, there is another method to solve this question, and that I can see from the options. Look at all the options. All the options have four terms. The number of terms is 4. You can see these are the terms. This is a term, 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 and term. So total 4 terms. Every option has 4 terms and equal number of literals. What it means? It means that I can just find the min term list from these options. For every option, I can find the min term list, and then I can compare with the given min term list. If they match, then that will be minimal SOP expression. See why I am saying this, because please understand, one thing is confirmed, that at least one of these options is correct. Okay, means for this function f, the minimal SOP expression will have 4 terms and how many literals? 2 plus 2 plus 3 plus 3. Okay, so you can see 4 plus 6, total 10 literals. This is confirmed. Do you agree with me? This is guaranteed that for this function f, the minimal SOP expressions, all the minimal SOP expressions will have 4 terms and 10 literals. Now, if I find the min term list for any option, and if that min term list matches the min term list of function f, then that expression will definitely be minimal SOP, because that has 4 terms and 10 literals. Okay, is this clear? Remember, very important point. For any function, minimal SOP may not be unique. You can have one or more minimal SOP expression, but in all the minimal SOP expressions for a function f, the number of terms and number of literals will be same. If you have a minimal SOP expression which has 4 terms, 10 literals, then all the remaining minimal SOP expressions will have 4 terms, 10 literals. This is an important point I told you in our lectures also, that for any function f, the minimal SOP expression may not be unique. You can have one or more minimal SOP expression, but in all the minimal SOP expressions, the number of terms and number of literals will be same. Okay. So here, the from the options, I can see that I can apply this method also, that I can find the minterm list for every option, and then I can check, then I can compare with the given minterm list. Or you can apply the K-map. Okay, that is your choice. So let me solve this question by both the methods. Let me solve the question first by the method of minterm list. Okay, let me find the minterm list, and then we will solve this question by the K-map also. Okay, so let's see for option A, method 1. In the method 1, what we will do, we will find minterm list for each option. Okay, now let's find for option A, then we will find for option B also. So let me focus on option A. Here you can see the order of variables is PQRS. This is given to you. P is the most significant, S is the least significant. And remember, by default also the order of variables is alphabetical order. So here let's find the minterm list. This SOP expression is given to you. From the SOP expression, finding the minterm list is actually very easy. What you will do, notice one thing. This is SOP expression, but these are product terms, but these are not minterms. What is a minterm? Minterm is a product term containing all the variables. You can see here the variable P is missing. Here the variable Q and R both are missing. Okay, so you can see that these are product terms. These are product terms, but they are not minterms. Minterm is a product term containing all the variables. Okay, so what we will do? We will just see what are the missing variables, and in those positions we can put 0 or 1. Okay, very simple. So here this product term will represent total 4 minterms. Okay, how you can see, what about this p bar s, p bar s, p bar s, and the order of variables is pqrs. So here you can see, because of p bar I will write 0. Remember, this product term will represent which minterms? So you can see p bar means 0, because for any input combination, when we write the corresponding minterm, then if a variable is 0, then we write it complemented. If a variable is 1, then we write without complement. Okay, you can see here this p bar, this is complemented, so I can say that I will write 0 here. And this s, this is the least significant variable, and this s is without complement, so I will write 1 here. And you can see these two positions, these are available. Okay, because q comma r, they are missing in this product term. So here I can write either 0 or 1. Okay, in these two positions, here I can write 0 or 1, here I can write 0 or 1. So overall total 4 minterms I am going to get. Okay, those 4 minterms will be like this. What I can do, here I can put 0 0, here I can put 0 1, here I can put 1 0, here I can put 1 1. Okay, so these 4 minterms I am going to get. Here you can see this is the minterm 1, this is the minterm 3, this is the minterm 5, and this is the minterm 7. These are the minterms that I got. Okay, now what about this QR bar? Notice one more thing here. In all the options I have p bar s, so I don't have to find this again and again. Just one time I have to find p bar s, that I have found. Okay, let's find QR bar. This QR bar, this is the product term, but this is not a minterm because here variable ps both are missing. Okay, so this product term will represent a group of minterms. And how to find the group of minterms that are represented by this product term? Very simple. Here you can see variable p is missing, and p is the most significant variable, so variable p is missing. Then you can see q is without complement, so I will write 1. Then you can see r is with complement, I will write 0. And then you can see s is missing. Okay, so very simple. Here I can say total 4 minterms will be represented by this product term QR bar. Very simple. In these two missing positions, here I can write 0 or 1. Here I can write 0 or 1. Okay, so I will get 0 0, 0 1, 1 0, 1 1. Okay, what are the min terms that I got? You can see I got min term 4, I got min term 5, this is the min term 12, and this is the min term 13. Okay, very simple. Now you can see in all the options I have QR bar, so I don't have to calculate it again and again. Okay, now what we need to do, let's find what are the min terms represented by these two product terms. Okay, so let's find for P bar, Q bar, R. Okay, here you can see the variable S is missing, correct? So here basically this product term will represent total two min terms, because here, because of this P bar I will write 0, Q bar I will write 0, R I will write 1. Okay, and here S is missing, so here I can write either 0 or 1, so total two min terms I will get. You can see 0 0 1. You can see here I can write 0 or here I can write 1. So I got min term 2, I got min term 3. And what about Q bar, R, S bar? Q bar, R, S bar. What are the min terms represented by this product term? So here P is missing. P is missing. Variable P is missing. And you can see because of Q bar, because this is complemented, so I will write 0. R is without complement, I will write 1. Because of S bar, I will write 0. Okay, this you already know that for any input combination, how to write the min term. For any input combination, you will see if a variable is complemented, if a variable is 0, then I will write that variable complemented. If a variable is 1, then I will write that variable without complement. That you already know. Okay, so here you can see this variable is complemented, so I will write 0. This variable is without complement, I will write 1. And you can see variable P is missing, so I can write 0 or 1 here. I can write 0 or I can write 1. Okay, so here you can see I got min term 2 and this is the min term 10 I got. So from the option A, for option A, what is the min term list? What is the min term list I got? So you can see I got 1 3 5 7. So I got 1. Then you can say I got 2 also. Okay, I got 2 also. 1 2 3. I got 4 also, 5 also. 1 2 3 4 5. This is what I got. 1 2 3 4 5. Then you can see I did not get 6. Then I got 7. Okay, so you can see 1 3 5 7. 1 3 5 7 I got. Then 4 5 12 13. 4 5. Then I got 12 also. I got 13 also. Then 2 3 I already got here. And this 2 10. And this 10 also I got. Okay, this is the min term list for option A. Can you notice this option A min term list does not match with the min term list of the given function f? Because here you can see I have 14 also here, but in the option A, 14 is missing. Correct? I have 13, I have 12, but I don't have 14. Okay, so you can see I have 1, 2, 3, 4, 5, 7, 10, 12, 13. Okay, this is what I have for option A, but 14 is missing. So definitely I can say that option A is wrong. Option A does not represent the minimal SOP expression for the given function f. Option A actually does not represent the function f. So option A is definitely wrong. Now you can find the min term list for option B, C, D. And remember, when you find the min term list for option B, C, D, then you don't have to basically find the min terms for these product terms. Okay, min terms represented by these product terms you don't have to find, because we have already found P bar S, Q R bar. We have already found. Okay, so the work that you have already done, you don't have to do that again. Okay, the new work you can do. For example, for option B, P bar, Q bar, R also we have already found. So we just need to find P, R, S bar. Okay, so let's see for option B now. For option B, already we have this P bar S, Q R bar. These we have already found. Okay, so you can see some of min terms and the min term list. This P bar S represents which min terms? This will represent 1 3 5 7. 1 3 5 7. Okay, next QR bar represents which min terms? These are the min terms represented by QR bar, that is 4 5 12 13. Okay, 4 5 12 13. 12 13. Okay, and what about P bar Q bar R? P bar Q bar R, that will represent 2 comma 3. Min terms 2 comma 3. 2 comma 3. Okay, now I just have to find what are the min terms represented by PRS bar. PRS bar, it will represent which min terms? Here you can see the variable q is missing. Okay, so remember, this is not a min term, this is a product term, but this is not a min term. Min term is a product term containing all the variables. Here the variable q is missing. So let's see what are the min terms represented by this product term. Here you can see this p, comma, p and r, they are without complement, so I will write 1 1. And notice one thing, that q is the second variable from the left. Okay, so you can see this q is missing actually. This q is missing. Q is the second variable from the left. This is the order of variables, and q is the second variable from the left. Okay, so you can see r means 1 and s bar means 0. Okay, so what are the min terms that I will get? Here you can see that here I can put either 0 or 1. I can put 0 or I can put 1. Okay, so you can see I got min term 10, and here I got min term 14. I got 10 comma 14. 10 and 14. Now you check this minterm list, does it match with the minterm list of the given function f? I have 1 2 3 4 5, then I have 7 10 12 13 14. Yes, it matches. So option B is definitely one of your answer. Okay, option B is your answer. But remember, this is MSQ question, so I have to check option C comma D also. Okay, for option C, I don't have to find the minterm list corresponding to P bar S, Q R bar, because I have already found. Okay, also P R S bar I have already found in this option B. Okay, so basically the new work I will do, I will not repeat the same work. So let's see the minterm list for option C. For this option C, already which minterms we have found? You can see the minterms represented by these product terms P bar S, Q R bar. What are those? You can see P bar S represents these minterms 1 3 5 7. 1 3 5 7. Okay, then QR bar represents which minterms? 4 5 12 13. 4 5 12 13. Okay, then you can see PRS bar represents which minterms? PRS bar represents minterm 10 comma 14. Minterm 10 comma 14. Okay, now I just have to find what are the minterms represented by this product term. This product term PQS bar. PQS bar. This will represent which minterms? Here you can see this is not a minterm because here the variable r is missing, and variable r, that is the third variable from the left. Okay, so you can see what are the minterms represented by this product term PQ. So I will write 1 1, then r is missing, then s bar I will write 0, because remember the variable r that is missing, that is the third variable from the left. Okay, so very simple. Now you can see in this missing position I can either put 0 or 1, so I can put 0 or I can put 1. So I got minterm 12 I got, and minterm 14 I got. Okay, minterm 12 comma 14 I got. So you tell me, this option C minterm list, does it match with the minterm list for the function f? No, they do not match. Correct, because here you can see I have 2, but in the option C minterm list I don't have 2. So option C does not represent the given function. Okay, very simple. I hope you understood. What about option D? For option D, I will find the minterm list, but I don't have to do the repeated work. Here you can see P bar S, QR bar, PQS bar, and Q bar RS bar. Actually, for all these product terms, the minterms that are represented by them, that we have already found. Okay, so let's see for this option D. For this option D, what will be the minterm list? So you can see what are the minterms represented by P bar S? We have already found this P bar S will represent minterms 1 3 5 7. Okay, 1 3 5 7. Next, what are the minterms represented by QR bar? QR bar will represent minterms 4 5 12 13. 4 5 12 13. What are the minterms represented by PQS bar that we have found in the option C? PQS bar. PQS bar will represent 12 14. 12 14. What about Q bar or S bar? This product term will represent which minterms that we have found in the option A? Q bar or S bar. So you can see Q bar or S bar, this product term will represent min terms 2 and 10. Okay, 2 and 10. Now you see this option D min term list, does it match with the min term list of the given function f? You can see 1 2 3 4 5, then 7 10 12 13 14. Yes, so I can say option D, that is also another answer. Okay, so for this question the answer will be option B and D. Okay, for this question the final answer that we have found, that will be answer B and D. Okay, so this is the method 1. In this method we are finding the min term list corresponding for all the options, and then we are matching with the min term list given for the given function f. Okay, very simple. I hope you understood this method. And remember, I can apply this method. The reason is very simple, because in all the options I have 4 terms and 10 literals. Okay, so that is the reason I can apply this method here. But remember, if different options have different number of terms, different number of literals, then the only method that you should apply, that is k-map. Please understand, in the same question, in the options, if you have different number of terms, different number of literals, then the only method you should apply, that is k-map. Okay, so let's apply the k-map also for this question. Let's solve this question by the k-map method. So method 2, that is k-map, because for this type of question where the question is asking for minimal SOP expressions, k-map will come to your mind. Correct? Okay, so let's apply the k-map method here. Let's make 4 variable k-map. So this is the given function, and the 4 variable k-map I can create. Let me put the variables PQ on the column. Let me put the variables RS on the row. Okay, 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Okay, so this is the k-map, 4 variable k-map, and let me label the area also. Here you can see that this is the area for P, this is the area for Q, okay, and this is the area for R, and this is the area for S. Okay, very simple. Now let's fill this k-map. You can see when I put the most significant 2 variables on the column and the least significant 2 variables on the row, then what is the numbering? What is the cell numbering? Do you recall? Then the cell numbering is like this: 0 1 2 3 4 5 6 7 8 9 10 11, then 12 13 14 15. Okay, this is the cell numbering. Now let's fill this k-map here. So you can see for these cell numbers the function value is 1. Okay, so let me put it here. You can see 1 2 3 4 5. Okay, so you can see this is 1, this is 2, this is 3, then this is 4, this is 5. Okay, so you can easily see here 4 5, and these are 1 2 3. Okay, so after that you can see very 7. So you can see 4 5 6 7, this is 7, then 8 9, this is 10, then 11, then 12, then 13, then 14. Okay, so very simple. Like this you can fill the k-map. Now after filling the k-map, we need to find the minimal SOP expression. And remember, this is MSQ question, so there can be one or more minimal SOP expressions. So the best thing is that you find all the EPI, you find the prime implicants, you find the EPI, and then of course in the minimal SOP you will include all the EPI, all the essential prime implicant you will include. Correct? Okay, so first let me find all the PI, let me find all the EPI. Okay, so let's find all the PI first, prime implicants. What is a prime implicant? It is cube covering ones which is as large as possible. Can I make a cube of size 8? No, cube of size 8 is not possible. So the maximum size cube covering ones I can create, that is size 4. Okay, so here you can see that this size 4 cube I can create, this is a PI. Then you can see this size 4 cube I can create, this is a PI. Is there any other PI? Is there any other prime implicant of size 4? Size 4 prime implicant, can I create any other? No, that's it. Okay, so these are the size 4 prime implicants. Now I will see the size 2 prime implicants. Correct? So let's see. You can see this will be a prime implicant. Notice one thing, that another prime implicant will be this corner, like this. This is another prime implicant. Okay. Is there any other prime implicant? You can see this one is also prime implicant. Okay. Do we have any other prime implicant? Let's check. From this one point of view, yes, you can notice there is another prime implicant from this one point of view. Look at from this one point of view. From this one point of view, you can see that this is another prime implicant. Let me use a different color. You can see this is a prime implicant. Okay. Do I have any other prime implicant? See, let's see from every one point of view. Let's see. Let's make sure that we do not miss anything. So you can see from this one point of view, I have checked everything. From this one point of view, you can see this is a useless neighbor. This is a useless neighbor. Okay, so the useful neighbors I've already considered. Then you can see from this one point of view, useless neighbor, and I have considered the useful neighbors. Okay, so do I have any other prime implicant? No, the answer is no. So these are the prime implicants. Okay, you can see here, these are the PIs. Total, how many PIs I have? You can see 4 size PI, that is 2. Okay, so 2, then you can see 3, 4, then 5, 6. Total 6, I think. Okay, you can see, you can check 2, then 3, then 4, then 5 and 6. Yes. So the number of PI are basically 6. Now you find what are the EPI. To find what are the EPI, you just see what are those one cells which are covered uniquely by a PI. Okay, very easy. What you do, you find those one cells which are covered uniquely by a PI, means only one PI covers them. Okay, you can notice, look at this one cell. This one cell is covered only by this orange PI. So this orange PI, this is a EPI. This orange PI, this is a EPI, means it will be part of every minimal SOP expression. This is essential prime implicant. To cover this one, we have to use this PI. Yes or no? This orange PI. Because this orange PI covers this one cell uniquely, so this orange PI is EPI. Is there any other one cell which is covered uniquely by a PI? You can see this one is also covered uniquely by a PI, but that is orange PI, so that we have already considered. Okay, you can see, look at this one cell. This is also covered uniquely by this green PI, so this green PI, this is also EPI. Okay, is there any other one cell which is covered uniquely by a PI? Look at this one cell, this is also covered uniquely by this green PI, so this green PI is EPI, that we have already considered. Okay, just see any other one cell which is covered uniquely by a PI. No, there is no other one cell which is covered uniquely by a PI. Okay, so there are only two EPI, that's it. So please understand, to find EPI, what I am doing, I am finding those one cells which are covered uniquely by a PI. So first you find all the PI, then you check all the one cells, and you see, are they covered by a PI uniquely? If they are covered by a PI uniquely, that PI will become EPI. And that EPI, all the EPI, they are part of all the minimal SOP expression. Now, what are the product terms? So you can see, for this EPI, for this orange EPI, what is the product term? This is in the area of Q and R bar. Okay, so that is R bar Q. Q R bar, because the order of variables, that is PQRS. So I can say that QR bar. What about this green PI? This green EPI. So what is the product term? This is in the area of P bar. This is in the area of S. So P bar S. So let's write the minimal SOP now. In the minimal SOP, all the EPI I have to take. So I have to take P bar S. I have to take QR bar. These I have to take. But remember, all the EPI, are they collectively covering all the one cells? No. Many one cells are still remaining. Okay, yes or no? So I need to add some more pi, I need to add. And now what I will do, these API I have already taken, so means these one cells. Okay, basically look at these one cells. These one cells I have already considered, or I can say I have already covered. Now how many one cells are remaining? These three one cells are remaining. Okay, these two and this. So you can see, to cover these three one cells, I will use minimum number of pi. Okay, then I will get my minimal SOP expression. So what are the chances, what are the choices I have? My target is clear that I have to cover these three one cells with minimum number of pi. Okay, so what I can do, notice, I can use this pi. One thing is confirmed, that I need to take two pi, because there is not a single pi which can cover all these three one cells. Correct? Do you agree with me? To cover these three one cells, I don't have a single pi which can cover all of them. So I can say that I need to take two pi. Two pi will definitely cover these three one cells. Okay, so I need to take two pi, I need to take. Now what are those two pi that I need to take? Okay, so notice one thing, I can take pink this pink pi I can take. Okay, so let me take this pink pi. And to cover this one, I can take this blue pi. Okay, this blue pi. So remember what I am doing, I am taking this blue pi, I am taking this pink pi. Okay, so blue pi, what is the product term for blue pi? This is in the area of q bar r s bar. Okay, you can see q bar r s bar. So I can say q bar r s bar. What about this pink pi? This pink pi, this is in the area of r p s bar. Okay, p r s bar, p r s bar. Okay, so this pink pi I am taking. So that's it, I got minimal SOP. One of the minimal SOP I got. I can find many other minimal SOP. Okay, so let's find another minimal SOP. Notice I need to take two pi to cover these three one cells. Already this pink and blue I have taken. Okay, pink and blue I have already considered. Now what I can do, I can take this pink. Okay, this pink I will take. Also pink comma blue I have already considered, so with pink, now to cover this one I can use this red. Okay, pink comma red. So let me take pink and red. Okay, very simple. What other I can do? So remember pink comma red. Now with pink or red, with pink and red, these three one cells I can cover. Okay, with help of 2 pi. Very simple. What are other possibilities? I need to cover these three one cells. Correct? So what are other possibilities? See, if I take this pink one, then to cover this one, either I have to take blue or I have to take red, that I have already considered. So now I will not take the pink one. Okay. So what I will do? I cannot take the pink one. So what I can do? I can take the blue one. Notice I can take the blue one. If I take the blue one, then these two ones are covered. Now to cover this one, I need to take yellow. Yes or no? This yellow I need to take. Very simple. So blue, yellow I need to take. Is there anything else I can do? Pink I cannot take. If I take blue, then to cover this one, I need to take yellow, that I have already considered. So that's it. All the minimal SOP I have already considered. Okay, yes or no? So basically there will be three minimal SOP. Please understand. There are total three minimal SOP. You can see this is the minimal SOP where I have taken blue pink. This is another minimal SOP where I have taken pink red. Okay, so you can see what is pink. This pink is in the area of R P S bar. Okay, P R S bar. Okay, so this pink is P R S bar, and this red, this is in the area of P bar R, Q bar. Okay, P bar, Q bar, R. So P bar, Q bar, R. Okay. So you can see this is minimal SOP 2. I can say that this is the minimal SOP. This is the minimal SOP 2. And you can notice this was the minimal SOP 1. And what about another minimal SOP? This blue, yellow, if I take, then that will be another. So you can see this blue and this yellow. Okay. So you can see this blue. This is in the area of Q bar, S bar, R. Okay. Q bar, R, S bar. So you can see Q bar, R, S bar. And what about this yellow? This is in the area of P, Q, S bar. P, Q, S bar. Okay. So this is your minimal SOP 3. So total 3 minimal SOP we have. I hope you understood. Now you can see what option is correct, what option is not correct. You can see all the 3 minimal SOP have P bar S, Q R bar. Okay, so remember P bar S, Q R bar, these are present in all the 3 minimal SOP. Okay, now let's see. Do I have this minimal SOP P bar, Q bar R? You can see I don't have here P bar, Q bar R. P bar, Q bar, R I have, but with that I have P R S bar. So you can see with P bar, Q bar, R, I have P R S bar. With P bar, Q bar, R, I have P R S bar. So you can see that option A, it is not a minimal SOP. Is this clear? Very easy, right? Okay. So you can see option A, that is definitely not correct. What about the option B? P bar, Q bar, R, P R S bar. Yes, that is my minimal SOP 2. P bar, Q bar, R, P R S bar. So you can see P bar, Q bar, R, P R S bar. This is my minimal SOP 2. Okay, so you can see yes, this is the correct option. What about option C? PQS bar, PRS bar. So you can see I don't have here PQS bar. I don't have here PQS bar. In the minimal SOP 3, I have PQS bar, but with that I have Q bar, RS bar. So you can see that I don't have option C also in my minimal SOP list. Okay. Now what about option D? PQS bar, Q bar, RS bar. PQS bar, PQS bar, Q bar, RS bar. Yes. So option D, option D is my minimal SOP 3. You can see PQS bar, Q bar, RS bar. PQS bar, Q bar, RS bar. This is my minimal SOP 3. Okay, so yes, option D, that is also correct. Okay. And remember, there is one more minimal SOP. For this function, there are 3 minimal SOP. 2 are already written, and the last one also let me write. The minimal SOP 1 also let me write here. That will be P bar S or Q R bar or the minimal SOP 1. P bar S, Q R bar, Q bar R S bar, Q bar R S bar or P R S bar. P R S bar. Okay. So you can see this is not in the options. This Q bar R S bar, you can see with P R S bar. Okay. So that is actually not present in the options, but I'm just saying that this is the complete analysis that for this given function f, there are 3 minimal SOP and all the 3 minimal SOP we have found. So this was your method 2, that is K-map. Using K-map also you can solve this. Tell me which method did you like for this question? Particularly for this question, which method did you like more? We have seen 2 methods. The first method was finding the min-term list for every option, and the second method is K-map method. For this particular question, which method did you like more? Again, remember one thing, that if different options have different number of terms and different number of literals, then you cannot use method number 1. Then you have to use the K-map method. For this type of question where the question is asking minimal SOP, minimal POS, basically minimal expression, if the question is asking, then the best method is K-map only. But because here all the options have same number of terms, same number of literals, so I can use the method number 1, that is finding the minterm list for all the options. Okay, I hope you understand both the methods, then you can decide that for this question which method is better, or then you can decide which method is your favorite. Okay, but understand everything. With every method you are understanding, you are revising your concepts. Okay, so this is the complete analysis of GATE-CS 2026 question. Now let's move on. Let's all GATE 2026 question. Consider the following 4 variable boolean function f a b c d. Sum of minterms expression is given to us. For these indexes, for these row numbers, or I can say for these input combinations, the function value is 1. This is the minterm list, and this function is over 4 variables. This is the order of the variables. You can see the variable a is most significant variable, variable d is least significant variable, and that is mentioned here. You can see variable a is most significant and variable d is least significant. Which of the following options represents the minimal SOP? Minimal SOP expression for this function f we need to find. And the question is saying that this is or operation, this is and operation, and this is not operation. So everything is standard basically. Okay, and the order of variables is also given in the question, and that is mentioned here also. Okay, so here and here basically the same information is given. And also remember, by default the order of variables is always alphabetical order. Okay, so let's find what will be the minimal SOP. Whenever the question asks you for minimal SOP, then always think about K-map. Okay, so you make a 4 variable K-map, then from the K-map you find what is minimal SOP. So let's find the K-map here. This is the given function. Let me make 4 variable K-map. Let me put variable AB, which are most significant variables. Let me put them on column, and let me put variable CD, which are least significant variables, on the row. Okay, so 0 0 0 1 1 1 1 0, this numbering you already know. This is the standard numbering of K-map. Okay, now what are the cell numbers? You can see when I put the most significant variables on the column and when I put least significant variables on the row, then what will be the numbering here? You already know the numbering will be basically, the cell numbering will be 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. This will be the cell numbering, correct? Okay, now you can fill the K-map. So you can see these are the minterms. This is the minterm list, or I can say for these cell numbers the function value is 1. So you can see the function value is 1 here. Okay, this is cell number 0. So you can see here the function value is 1, here the function value is 1, 0 1 2 3. Okay, so you can see 0 1 2 3, then 8 9 10 11. Okay, so you can see 0 1 2 3 8 9 10 11. This is the minterm list. So 8 9 10 11, where is that? 8 9 10 11. Okay, so that's it. This is your K map. Now from this K map we need to find what is minimal SOP. To find minimal SOP, to find minimal SOP expression, minimal sum of product expression, we will cover all the one cells with cubes which are as large as possible, and we will use minimum number of cubes. Okay, I told you that to find minimal SOP expression, we will make cube which are as large as possible, covering only the one cells, do not cover any zero cell, and use minimum number of cubes. Okay, here can I create 8 size cube? Yes, there is 8 size cube here. You can notice, look at this one, look at this cube. Remember the K-map I can fold horizontally, vertically. So you can see this last column and this first column, they are basically neighbors. Okay, or I can say that this is basically 8 size cube. Okay, so very simple, we got this 8 size cube, and what is the product term corresponding to this 8 size cube? Let me label the areas in this K-map. You can see the last two columns. Here the variable a is 1, so this is the area for A. You can see this is the area for B, this is the area for C, and this is the area for D. So for this green cube that we have created of size 8, what will be the product term? So you can see this is in the area of B bar, correct? Okay, this is in the area of B bar. So that's it. So I can say minimal SOP expression that will be B bar. Okay. For this question, the answer will be option B. Very easy. This question is actually very easy. Now let's move on. Let's solve GATE 2008 question. Consider the following Boolean function of four variables f, a, b, c, d. This is the order of the variables. A is most significant and D is least significant variable. Also, by default, the order of variables is alphabetical order. For this function, this sum of minterms expression is given to you. This is the minterm list, means for these row numbers, for these indexes, or I can say for these input combinations, the function value is 1. The question is asking the function is independent of how many variables. I told you that whenever the question asks you if some function is independent of some input variable or not, then always find the minimal SOP or minimal POS expression. Always find minimal expression for this type of question. Whenever the question asks you if some function is independent of some variable or not, then what you do, basically you find minimal expression. You find minimal expression. You can find minimal SOP or minimal POS, that is your choice, but you find minimal expression. Okay. And in the minimal expression, if some variable is not present, then we will say that this Boolean function is independent of that variable. In the minimal expression, all the variables which are present, we will say that this Boolean function is dependent on those variables. Okay. So for this type of question, which is asking if a Boolean function is independent or dependent on some variable or not, then always find the minimal expression. And remember, to find the minimal expression, the best method is K-map method. Okay, K-map gives the guarantee that you will find minimal expression, minimal SOP or minimal POS you can find with help of K-map. Okay, so let's make the K-map here. We need to make 4 variable K-map. The variables are A, B, C, D. So you can see this is the 4 variable K-map where variable A, B, which are most significant variables, I have put on the column, and the least significant variable C, D I have put on the row. Okay, now what is this function here? The minterm list of function is given to you. So the function is over 4 variables A, B, C, D. And you can see the minterm list, that is 2, 3, 6, 7, 8, 9. 2, 3, 10, 11, 12, 13. Okay. Now let's see. Let's fill this K-map now. I told you in the 4 variable K-map, when you put the most significant 2 variables on the column and least significant 2 variables on the row, then what will be the cell numbering? Here the cell numbering, remember, that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now you can easily fill the K-map. So let's fill it. You can see 2, 3, 6, 7. So this is basically 0, 1, 2. Okay. So I can say this is 2, this is 3. Then 6, 7. You can see 4, 5, 6, 7. Then 8, 9, 10, 11. Then 12, 13. Okay. So you can see this is the minterm list 8, 9, 10, 11, 12, 13, and 2, 3, 6, 7. Okay. So you can see this is the K map. We have filled the K map. Now let's find the minimal SOP. To find minimal SOP, what we need to do? We need to cover all the 1 cells with minimum number of cubes and every cube as large as possible. Okay, yes or no? So you tell me, covering 1 cells, can I create a cube of size 8? No, cube of size 8 is not present here. Okay, so I need to make cube of size 4 or cube of size 2 or cube of size 1. Basically, the maximum size cube I can create covering ones that will be size 4 cube. Okay, so you can see this will be a size 4 cube. I can say this is prime implicant. Another size 4 cube I can create here. There is another size 4 cube. You can see this corner cube, you can notice. Okay, basically I can fold the K map horizontally, vertically. So you can see this 4 size cube I can create. There is another 4 size cube. This is another 4 size cube. Look at this. Okay. Is there any other prime implicant? Remember, these are prime implicant. What is a prime implicant? Prime implicant is a cube covering ones which is as large as possible. Okay. So in this K map, do I have any other prime implicant? These are the four size cubes, or I can say 4 size prime implicants we have created. There is no other prime implicant. There is no 2 size prime implicant. There is no 1 size prime implicant. That's it. These are the prime implicants. Okay. So actually here you can easily see some extra information. Let me share with you that the number of PI, the number of prime implicants, that is 1, 2, 3, 4, total 4. And tell me how many of them are EPI, essential prime implicant. To find essential prime implicant, first you find prime implicant, all the prime implicants we have found, then you find what are the one cells which are covered uniquely by a PI. So you can easily notice that this one cell, this is uniquely covered by the orange PI. So this orange PI, this is a EPI. Okay, you can notice this one cell is also covered uniquely by a PI, but that is orange PI, so that is already EPI, we have already mentioned. Okay, so very easy point, that these are the one cells which are covered uniquely by a PI. Also you can see this one cell, this one cell, so they are covered uniquely by this pink PI. Okay, so this pink PI, this is also EPI. Is there any other one cell covered uniquely by a PI? Let's see. You can see these one cells, they are covered by blue PI, also green PI also. These one cells, they are covered by pink PI and green PI. Okay, these one cells are covered by this orange PI, blue PI. So I can say that that's it. These are the only one cells. I have already put the star. Okay, these star marked one cells, these are the only one cells which are covered uniquely by a PI. Means only one PI covers them, and those PI will become EPI. So total 2 EPI we have. Now let's write the product term here. So let me label the areas in this K map. Let me label the areas. You can see this is the area of A. Then you can see this is the area of B. This is the area of C. This is the this middle 2 rows. That is the area of D. Okay. Now what will be the product term for this orange EPI? This is in the area of A. This is in the area of C bar. And what about this pink PI or pink EPI? This is in the area of C A bar. A bar C. So that's it. These are the EPI. So the minimal SOP will contain all the EPI. All the EPI will belong to all the minimal SOP. So you can see A C bar, A bar C. Did I cover all the one cells? You can see these one cells I have covered. You can see these one cells I have covered. But still, these two one cells are remaining. These one cells are still remaining. So I need to cover them. Now, to cover them, I need to use minimum number of PI. Okay. Now here actually you can notice, to cover these one cells, either I can use the green PI. What I can do, either I can use the green PI. You can either use the green PI. The green PI that is in the area of B bar and C, B bar C. Okay, so remember, if you use this green PI, then now you can see all the one cells are covered. So this is your minimal SOP 1. This is the minimal SOP expression 1. But remember, there is another minimal SOP. What that is? You can see, to cover these one cells, I can use the blue PI. Correct? Okay, I can use the blue PI. So for this blue PI, what is the product term? This is in the area of A and B bar. Okay, so that will be AB bar. Correct? So you can see that this is another minimal SOP expression. Minimal SOP expression 2. Is there any other minimal SOP expression? No, that's it. These are the two minimal SOP expressions. Okay, and now you can see, In this minimal SOP expression, you can see the function depends on variable a, c, b, correct? And you can also look at this minimal SOP expression. Here also the function depends on a, c, b. I told you, you just have to find a minimal SOP expression or minimal POS expression. You just have to find any one minimal expression. You don't have to find all the minimal expression. You don't have to find all the minimal SOP. You don't have to find all the minimal POS. See, for this question, I have found two minimal SOP expression, but I don't have to do that. I just need to see if this function is independent of some variable or not. And for that, any minimal expression is fine. If you give me any one minimal SOP or minimal POS expression, any one minimal expression, if you give me, then I can answer this question. I don't need all the minimal SOP expression. Okay. So remember, for this question, I can say that this function is independent of variable d. You can see in the minimal expression, we don't have variable d. So I can say that this function is independent of variable d. So independent of one variable. So you can see answer will be option A. Okay. Very simple. I hope you understood this question and this solution. Now we will cover some gate PYQs based on the topic combining Boolean functions. And actually this concept and some gate PYQs we have already done in this lecture. On YouTube, you can search combining Boolean functions go classes. Okay, so you can see this on YouTube, you can search combining Boolean functions go classes. Okay, and in this lecture, I have already covered how to combine Boolean functions with respect to min terms, with respect to max terms for any Boolean operation, and operation, not operation, or operation, NAND, XOR, XNOR, NOR. Basically, for all the Boolean operations, how to combine two Boolean functions with respect to min terms, with respect to max terms, and some gate PYQs, and the complete theory that is covered in this single lecture. Okay, so if you did not watch it, then you must watch it, and you can search on YouTube combining Boolean functions go classes. Okay, now let's solve some more gate PYQs based on this topic combining Boolean functions. Let's solve gate 1988 question. Three switching functions. Switching function means Boolean function. So three Boolean functions f1, f2, f3 are expressed below as sum of min terms. So f1, f2, f3 over four variables w, x, y, z. This is the order of variables where w is most significant and z is least significant variable. And you can see sum of min terms expressions are given to you. Express the function f realized by the circuit shown below as sum of min terms. So this function f I need to write as sum of min terms. So this is actually very easy question. First you find the expression for f. First you write this f in terms of f1, f2, f3. Okay, you can see what this f will be. This function f, this actually will be, you can see f1 and f2 because this is the AND gate. So the output will be f1 and f2. Then you can see this is the OR gate. So you can see f will be equal to f1 and f2 or f3. This is the function f, correct? Now we need to express function f as sum of min terms. And remember, the sum of min terms expression for f1, f2, f3 is given to you. Okay. So here you can notice one thing. I need to combine two functions with respect to operation and also with respect to min terms, because here the min term list is given to you. So I need to see how to combine two functions for operation and also how to combine two functions for operation or. Okay. Actually, this concept we have already seen, but let me just quickly do the revision here, or let me write the note or conclusion here. So let's see the note. If a function f1 is given to you as sum of min terms, let's assume this min term list L1, and this function f2 has the min term list L2. Okay. So basically two functions are given to you as sum of min terms, means the min term list is given to you. Then what will be f1 and f2? What will be f1 or f2? Okay, so let's find that. What will be f1 and f2? Tell me, what will be the min term list for f1 and f2? What do you think? See, You don't have to remember anything, you don't have to by heart anything, just use the logic. You can see this L1 and L2, these are the minterm list of F1 F2 respectively. So I can say that for these input combinations F1 is 1, and for these input combinations F2 is 1. Tell me, when this F1 and F2 will be 1, I want the minterm list of F1 and F2, means I want those indexes, those row numbers, or I can say those input combinations where F1 and F2 is 1. Because I want sum of minterm expression for F1 and F2, I want minterm list of F1 and F2. So I want to see where F1 and F2 will be 1. F1 and F2 will be 1 for those input combinations where both F1 and both F1 and F2 are 1. Do you agree with me? F1 and F2, this function will be 1 for those input combinations where both F1 and F2 are 1. Okay, so remember, I need to find the intersection of L1, L2, these list. Yes or no? This is the list. This is the minterm list of F1. This is the minterm list of F2. So remember, this is a set, and this is also set. This is set of minterms of F1. This is the set of minterms of F2. I need to find the intersection. Why I am finding the intersection of these two? Because F1 and F2 will be 1 for those input combinations, for those indexes where both F1 and F2 are 1. Okay, and you can see F1 is 1 for this set and F2 is 1 for this set. So I need to take the intersection to find those indexes, those row numbers where both F1 and F2 are 1. Okay, is this clear? Very simple. Now you tell me, what will be the expression for F1 or F2? What will be the minterm list for F1 or F2? I want the minterm list for F1 or F2. So remember, I want those row numbers, those indexes where F1 or F2 is 1. F1 or F2 will be 1 for an input combination if at least one of these two, either F1 or F2 or both, are 1. Correct? Yes or no? F1 or F2 will be 1 for an input combination for a row when, if and only if, either F1 or F2 or both are 1 for that row or for that input combination. So I can say that I need to take union. Yes or no? L1 union L2 I will take. Okay, because remember, for a row, for an input combination, if F1 is 1, then definitely F1 or F2 will be 1. Similarly, for a row, for an input combination, if F2 is 1, then also F1 or F2 will be 1. And if both are 1, then also F1 or F2 will be 1. So I can say I will take union here. Okay, is this clear? Now remember, here we are combining two functions with respect to minterms. What if we combine two functions with respect to max terms? Let's see another note. You can see, if function f1 is given to you as product of max terms, this max term list is given to you. Let's assume that is L1. This is the max term list of F1, and F2 is also given to you as product of max terms, and this is the max term list of F2. Now you tell me, what will be the expression for F1 and F2? What will be the expression for F1 or F2? So let's see first for F1 and F2. Means I want the max term list, or I can say product of max term expression for F1 and F2. So tell me, what should I write here? Should I do the intersection? Should I do the union? Tell me. You don't have to remember, you don't have to by heart, just use the logic. Notice one thing, I want the max term list of F1 and F2. Max term list means I want those row numbers, those indexes where F1 and F2 is 0. Okay, and remember, for an input combination, F1 and F2 will be 0 if and only if for that input combination either F1 is 0 or F2 is 0 or both are 0. Do you agree with me? Okay, so I can say that I will take the union of L1, L2. What is the reason? Because you can see, for any input combination, if F1 is 0, then F1 and F2 will be 0. For any input combination, if F2 is 0, then also F1 and F2 will be 0. So you can see, this L1, this is the max term list of F1, means these are the row numbers where F1 is 0. So for these row numbers, F1 and F2 also will be 0. So I need to put L1 here. Also remember, this L2, this is the max term list of F2, means these are the row numbers where F2 is 0. So for these row numbers, F1 and F2 will also be 0. So I need to put L2 also here. So that is the reason I am taking union. Okay, very simple. Remember, for this AND operation, with respect to min terms, we are doing intersection. You can see with respect to min terms for AND operation, we are doing intersection. And for this AND operation, with respect to max terms, we are doing OR operation. Okay, so understand, don't by heart, just understand. Now let's see what will be F1 or F2. Let's find the product of max terms expression, or I can say the max term list. Let's find for F1 or F2. So what should I write here? Tell me. Just use the logic. I want max term list of F1 or F2. Means I want those row numbers, those indexes, those input combinations where F1 or F2 is 0. F1 or F2 will be 0 if and only if both F1 comma F2 are 0. Yes or no? You can see for any input combination, F1 or F2 will be 0 if and only if for that input combination both F1 comma F2 must be 0. Yes or no? So I will take the intersection of L1 comma L2. Okay, very simple. For any input combination, F1 or F2 will be 0 if and only if for that input combination both F1 comma F2 must be 0. These are the input combinations where F1 is 0. These are the input combinations where F2 is 0. So I will take the intersection. The intersection will give me those input combinations where both F1 comma F2 are 0. And for those input combinations, F1 or F2 will be 0. So I can say I will take the intersection. Now notice one thing. For the OR operation, with respect to max terms, we are taking intersection. With respect to min terms, we are taking union. Okay. So I hope you understood. This is the conclusion. I hope you understood. Now let's see here. Tell me what will be the expression for F1 and F2. F1 and F2. Here you can see with respect to min terms. Okay. So we have already seen that for F1 and F2, with respect to min terms, how to combine two functions. So we will take the intersection of the min term list. Correct? Yes or no? So I can say the min term list of F1 and F2, that will be intersection of min term list of F1 comma min term list of F2. Okay, so the intersection that will be basically 0 1 2 0 1 2, then you can see 3 5 12. Okay, that's it. So this is the intersection 0 1 2. Okay, here very simple. So we got F1 and F2. Now remember, we have this F1 and F2, that is 0 1 2. Okay, and what is F3? What is F3? That is 2 4 5 8. So now what we need to do? Now we need to combine these two functions with respect to OR operation, with respect to min terms. Okay, yes or no? So I told you that for the OR operation, how to combine two functions with respect to min terms, you will take the union. You will take the union of these two min term list. So the union will be 0 1 2 4 5 8. Okay, that will be your answer. So remember, the function f has this min term list, or I can say this is the sum of min terms expression for function f. I hope you understood. Is this clear? Very simple question. Remember, you can watch this video, this combining Boolean functions Go classes. This you can search on YouTube, because here for all the Boolean operations, and, or, complement, XOR, XNOR, NAND, NOR, for all the Boolean operations with respect to min terms also, with respect to max terms also, I have discussed how to combine Boolean functions. So this lecture contains all the theory also and some gate PYQs also. So you must watch this video, okay, because there are many questions based on combining Boolean functions in the gate exam. So you must watch it. Okay, you can search on YouTube combining Boolean functions Go classes. Let's solve 2002 gate question. Consider the following logic circuit whose inputs are functions f1, f2, f3 and the output is function f. This function f is the output and the inputs are f1, f2, f3. These are the functions. And this logic circuit is given to us. Given that f1, f2, f, for f1, f2, for f, the expressions are given to you as sum of minterms. The minterm list is given to you. The question is asking the minterm list for f3. We need to find the minterm list for f3. Okay, so for this question, actually this question you can solve by multiple methods. There are many methods to solve this question, but the best method, that is, first you find the expression for f. Okay, you don't have to worry about this circuit. Forget about this circuit. We don't care about this circuit. What we care about, we only care about the expression for function f. Okay, so what you do, let's find the expression for function f. You can see there is a NAND gate here. So what will be the output of the NAND gate? That will be complement of AND. So you can see here you got f1 and f2 complement. And you can see there is an inverter here. So the output will be f3 complement. Here you can see this f will be equal to what? Again you have a NAND gate. So you will do AND, then you will do the complement. So you will see you will get f1 and f2 complement and f3 complement and then whole complement. Okay, this is the f. So what will be f? You can apply the De Morgan law. So when you apply the De Morgan law, you will get f1 and f2 or f3. Yes or no? When you apply the De Morgan law, then this and will become or. And you can see here there is a double complement, so it will become f1 and f2. There is a double complement, it will become f3. So you can see f is equal to f1, f2 or f3. Okay, that's it. Now you can easily solve the question. Now you don't have to worry about the circuit. You don't have to worry about NAND. You just have to think about and comma or. Okay, so remember, whenever there is a question based on combining Boolean functions with respect to min terms or max terms and with respect to some Boolean operations, then what you can do, you can simplify the expression, or you can simply find the expression for the function f. Okay, you can further simplify if there is a simplification possible. Okay, if there is some complicated expression is given to you, and then what you can do, you can simplify it. So here the further simplification is not possible. Yes or no? So let's continue. This f, we have f1, f2 or f3. Okay, so let me write it here. We got f. Remember, all the functions, they are over three variables x, y, z. And f is basically f1 and f2 or f3. Okay, and here you can see the expressions are given to you. What is f1? F1 is sum of minterms. The minterm list is basically 0, 1, 3, 5. F2, the sum of minterms expression is given to you. The minterm list is 6, 7. And remember, for f, not for f3, for f, the minterm list is given to you, that is 1, 4, 5. Okay, very simple. Now we need to find the minterm list of f3. This f3 we need to find. Okay, so let's see here. Notice this f is given to you, that is this expression is given for f. Okay, first let me find the expression for f1 and f2, because I have f1 also, f2 also. So let me find the minterm list for f1 and f2. Okay, so you can see f1 and f2, what will be the minterm list, where the minterm list of f1, f2 both are given to you. So what I will do here, for AND operation with respect to minterms, I will do the intersection. Yes or no? I will do the intersection. So the intersection actually will be empty. Yes or no? The intersection will be empty. So you can notice that this f1 and f2, here there is a empty. Here this is the empty set. Okay, because the intersection of these two minterm list, that is basically empty set. Okay, what you can see, you can see that f1 and f2, that is 0 in all the rows, or I can say for all the input combinations, f1 and f2 is actually 0. There is no input combination where f1 and f2 is 1. Okay, is this clear? See, very simple point. We need to combine f1 f2 with respect to AND operation with respect to minterms. We have already seen in the previous question how to combine two functions with respect to AND operation. We have seen with respect to minterms also, with respect to max terms also. So you can see for minterms, for AND operation, you will take the intersection of the minterm list, and for AND operation, for max terms, you will take the union. Okay, so everything we have seen, the revision we have done in the previous question, but here you can easily see that the expression for f1 and f2, that will be empty minterm list. Okay, that's it, very simple. So overall you can see that from here one thing you can notice, that f1 and f2, this is basically 0. Yes or no? F1 and f2, this is basically 0, because for all the input combinations f1 and f2 is 0. There is no input combination where f1 and f2 is 1. So I can say that f1 and f2, that is basically 0. In the truth table of f1 and f2, in the column of f1 and f2, you have all 0. So I can say f1 and f2 is 0. Now you tell me 0 or alpha, what is that? 0 or alpha, that is alpha. So you can notice that f is equal to 0 or f3, because this has become 0. So f is equal to 0 or f3. 0 or alpha, that is alpha. So I can say f is same as f3. F has become same as f3. The question is asking for f3, so that will be same as f. So the answer will be 1 4 5. Okay, this is the answer. So you can see f3 is same as f. F3 is same as f. So the answer will be option A. Okay, I hope you understood. Let's solve GATE CS 2019 question. Consider four variable Boolean functions. F1, F2, F3, these are Boolean functions over four variables. You can assume the four variables are A, B, C, D, which are expressed in sum of minterms. So you can see the sum of minterms expressions of F1, F2, F3 are given to us. For the following circuit with one AND gate and one XOR gate, the output function f can be expressed as, we need to find the expression for output f. Okay, the inputs are f1, f2, f3. So this question is basically based on combining Boolean functions. We need to combine Boolean functions for AND operation. We need to combine Boolean functions for XOR operation. Okay, this question you can solve by multiple methods. See, the method number one, that is, you combine the functions with respect to AND operation, you combine the functions with respect to XOR operation. Okay, so you must know how to combine Boolean functions with respect to XOR operation, also with respect to AND operation. That is method number one. What is method number two? If you don't know how to combine Boolean functions with respect to XOR operation, then what you can do, this XOR you can write in terms of OR and complement. Okay, because you already know how to combine functions with respect to AND or complement. Okay, so these are the two methods to solve this question. I hope you understood. Okay, now let's see the method number one. Means we will see how to combine two functions for AND operation, how to combine two functions for XOR operation with respect to minterm list, with respect to maxterm list. Okay, here actually the minterm list are given to you, so you need to care only about the minterm list. Okay, so let's quickly see the revision here. Let me quickly tell you how to combine Boolean functions with respect to XOR operation. For AND operation, most of you already know, but let me quickly write it. So you can see, if function f1 is given to you as sum of minterms, and this is the minterm list L1, f2 is also given to you as sum of minterms, and this is the minterm list L2. Now, what will be the expression for f1 and f2, f1 XOR f2? Let's see what will be the expression for f1 and f2. Means what will be minterm list for f1 and f2. You don't have to by heart anything, just apply the logic. You can see, I want minterm list of f1 and f2. So I want those row numbers, those input combinations where f1 and f2 is 1. Remember, for any input combination, f1 and f2 will be 1 if and only if for that input combination both f1 comma f2 are 1. Yes or no? So remember, here I will write those input combinations, those indexes, those row numbers I will write for which both f1 comma f2 both are 1. You can see for these row numbers f1 is 1, for these row numbers f2 is 1. So for intersection I will get, when I do the intersection I will get those row numbers where both f1 comma f2 are 1, and for those row numbers f1 and f2 will be 1. So I can say that the minterm list of f1 and f2, that will be intersection of minterm list of f1 comma f2. Okay, very simple. Now let's see what will be f1 xor f2. Let's see how to combine two boolean functions for xor operation with respect to minterms. So let's find the minterm list for f1 xor f2. Now just apply the logic, just apply the definition, nothing else. Just apply the definition of xor. Okay, you can see I want the minterm list of f1 xor f2. Means I want those row numbers where f1 xor f2 is 1. Correct? So you tell me, for any row f1 xor f2 will be 1 if and only if for that row f1 1 f2 0 or f1 0 f2 1. Do you agree with me? Remember, xor will be 1 when exactly one of the variable is 1. Okay, for example, if you have alpha xor beta, when can I say this will be 1? Alpha xor beta is 1 if and only if there are two situations, either alpha 1 beta 0 or or alpha 0 beta 1. Okay, do you agree with me? Okay, so the same concept we are applying here. We are applying the definition of xor operation. You can see I want the minterm list of f1 xor f2. So I want those row numbers where f1 xor f2 is 1. For any row, xor will be 1 if and only if for that row f1 0 f2 1 or f1 1 f2 0. Do you agree with me? So basically, what I need to do, I need to find the symmetric difference of L1 comma L2. Remember, these are set. Please understand. This is set of minterms of F1. This is a set. This is set of minterms of F1. And notice this L2. This is also a set. This is set of minterms of F2. Of F2. Okay. Now, what I can say, I can say that I need to take the symmetric difference of L1 comma L2. I need to take the symmetric difference of these two set, because I want those row numbers which are present here but not here, or which are present here but not here. Okay, yes or no? So overall, I can say that I need those row numbers. Okay, basically I need those indexes. I need those row numbers, or I can say those indexes where 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 you can see f1 1 and f2 0. Okay, where you can see f1 1 f2 0, or f1 0 f2 1. Okay, do you agree? The same thing I can also write that I am looking for those indexes which are in L1 not in L2, or in L2 not in L1. Yes or no? The same thing I can also write it, that basically I want those indexes. I want those indexes k such that you can see k belongs to L1 but k not belong to L2. K does not belong to L2, or k does not belong to L1 but K belongs to L2. Okay, yes or no? If you notice, this basically same as, this is same as symmetric difference of the set. Means I need to take the symmetric difference of L1 comma L2. This is called symmetric difference. In the set theory we study, yes or no? So this is called symmetric difference. What is symmetric difference? Let me quickly tell you. If you have two set, let's assume you have set L1, you have another set L2, then what is the symmetric difference? Symmetric difference is this area. This area is a symmetric difference. You can see this is the symmetric difference. And you can see in this area, you can see here, these are included in L1 but not in L2. These are included in L2 but not in L1. Okay, yes or no? So overall, this is the whole point, that if F1 is given to you as sum of minterms, and this is the minterm list of F1, F2 is given to you as sum of minterms, and the minterm list is L2, then remember F1 XOR F2. What will be the minterm list for that? That will be L1 symmetric difference L2. I hope you understood this point. Okay, and the logic also we have seen. Very simple. So let's solve this question now. Tell me what will be F1 and F2. For F1 and F2, for AND operation, with respect to minterms, what we will do? We will do the intersection of minterms list. Yes or no? Okay, so I can say the minterm list of F1 and F2, that will be intersection of minterm list of F1 comma minterm list of F2. So the intersection, that will be, you can see 2 will be there in the intersection. Then you can see 0, 2, 5, then 8 will be there in the intersection, 14 will be there in the intersection. Yes or no? Okay, the remaining will not be there in the intersection. So you can see 2, 8, 14. Yes, this will be F1 and F2. Now, once you have this F1 and F2, and this is F3. F3 is, you can see, F3 is written here. Okay, you can see here. So tell me what will be F? F is basically F1 and F2 XOR F3. Okay, I need to take the XOR of this function and also this function. Okay, so you tell me for XOR what I will do. For XOR with respect to minterm list, what I need to do? I need to take the symmetric difference. Yes or no? Okay, so the minterm list for XOR will be, I need to find the symmetric difference. Symmetric difference means those indexes which are present here but not here, or which are present here but not here. Okay, yes or no? So you can see, let's see what are the indexes which are present here but not here. So you can see 8 is present here but not here. So I will write 8 here. Also remember, what are the indexes, what are the row numbers which are present here but not here? So you can see that is 7, 11. 7, 11. Okay, so the final answer will be 7, 8, 11. The answer will be option A. I hope you understood. Okay, so this is how you can solve it. Please understand, here we are directly finding how to combine two functions with respect to XOR operation with respect to minterms. Okay, now the same question you can solve by converting this XOR and writing this XOR in terms of OR and complement. Okay, so if you are not comfortable with XOR, then you can convert this XOR in terms of AND or complement. Okay, so that's how you can solve it. We already know that alpha XOR beta, that is basically alpha bar beta or alpha beta bar, correct? Okay, now we also know that if a function is given to you, if a function f1 is given to you as sum of minterms, and let's assume this is the minterm list L1, then what will be f complement? Means what will be f1 complement? So tell me, what will be the minterm list of f1 complement? So you can easily see, for these indexes, for these row numbers, f1 is 1. So for the remaining, f1 complement will be 1. Yes or no? So to find the minterm list of f1 complement, we will just complement this list. Yes or no? This minterm list of f1 we will complement. Okay, very easy. Now also you know that if f1 f2 both are given to you as sum of minterms, and this is the minterm list of f2. Now how to combine them for or operation? Okay, for or operation means with respect to or operation, how to combine them with respect to minterms. So what will be the minterm list of f1 or f2? We will take the union. We have already seen this in the previous question. Okay, and you also know that f1 and f2, what that will be with respect to minterms. So what will be the minterm list of f1 and f2? That will be intersection. Okay, L1 intersection L2. So that's it. Now these concepts we can use and we can solve this question. So we already know that this f, this is basically f1 and f2 XOR f3. Okay. Now what will be this f1 and f2? For a moment, let me write it g. Let me write it g. G is basically f1 and f2. Okay. So this is G. So finally, I can say that this F is basically G XOR F3. Correct? Okay. Now let me write the expression for G. What will be the minterm list for G? So you can see that this is AND operation. So with respect to minterms, what will be the minterm list of F1 and F2? We will do the intersection. Okay. So here just do the intersection. So that will be basically 2, 8, 2, 8, 14. 2, 8, 14. Correct? Okay, you can see. Yes. So this is the G that I got. Okay, now I can write it here that I got G, that is 2, 8, 14. And what is F? You can see F is G XOR F3. G XOR F3. What is F3? What is F3? That is 2, 7, 11, 14. 2, 7, 11, 14. Okay. Now let's see what this G XOR F3 will become. This will become G bar F3. Okay. Or G F3 bar. Correct. So let's see what will be this G bar. Already we have this G. So I can write the minterm list for G bar also. Okay. What will be the minterm list for G bar? So you can see what I will do. I will take the complement of this list. Yes or no? So if I take the complement of this list, what I'm going to get? You can see I will get 0, I will get 1, I will get 3, then 4, 5, 6, 7, then I will get 9, 10, 11, 12, 13, 15. Okay, yes or no? This is G bar. Please understand. Okay, this whole thing, this is basically G bar. Okay, and F3, this is F3. Okay, this already is present here, or G is already present here. G, and what is F3 bar? Okay, so let me write that F3 bar. To find the minterm list of F3 bar, we will do the complement of this minterm list of F3, right? So if I do the complement of this minterm list of F3, I will get 0, 1, then 3, 4, 5, 6, then 8, 9, 10, 12, 13, 15. Okay, that's it. Now, finally, what I will get, you can see. Now I need to do the intersection of minterm list here and here. Okay, because now I am combining with respect to AND operation. Okay, so when I combine two functions with respect to AND operation, with respect to minterm list, so how to find the minterm list of AND operation? That will be intersection of minterm list of both these functions. Okay, so I will take the intersection here. So what I will get, if I take the intersection of this and this one? Okay, so I will get 7, I will get 11, I will get That's it. 7 comma 11 I will get. Yes or no? Okay. Or what will be the expression here? You can see here also there is AND operation. So I need to take the intersection of minterm list. Correct? Okay. So I will get intersection of minterm list. I need to take this minterm list intersection this minterm list. Okay. So that will be 8. That's it. 8. Okay. Now I need to combine these two functions with respect to OR operation. Okay, so what I will do with respect to minterms, I will take the union. Okay, so finally you will say that I will take the union and I will get 7, 8, 11. So that's it. So for this question, the answer will be option A. Tell me which method did you like more, the method 1 or method 2? Directly we are solving without writing this XOR in terms of AND or complement. That was method 1. And method 2, that is we are writing this XOR in terms of AND or complement, that is method 2. Which method did you like more, method 1 or method 2? Let me know. I think method 1 was better. Okay, and if you want to become expert in method 1, okay, then you need the knowledge of how to combine boolean functions. So remember, you can watch this session on YouTube. You can search combining boolean functions go classes. In this lecture I have covered how to combine two boolean functions for all the boolean operations, and complement or XOR, XNOR, NAND, NOR, for all the boolean operations, how to combine two boolean functions with respect to minterms also, with respect to max terms also. So complete theory and gate PYQs I have done in this session. You can watch it. You must watch it because there are many gate questions. There are many gate PYQs based on combining boolean functions. Okay. So let's see the next question. Let's solve gate CS 2015 question. The total number of prime implicants of function f w x y z, and this sum of minterms expression is given to you. So we need to find the total number of prime implicants, or I can say pi. So the best method is k map. You make the k map for f, and in that k map you find what are prime implicants. What is a prime implicant in the k map? It is a cube covering one cells which is as large as possible. That's it. You make cubes as large as possible covering one cells. Don't cover any zero cell. Okay. And here you can see this function f is given to you over four variables, over four variables w, x, y, z, where w is most significant variable, z is least significant variable. Okay, so this is the order of variables that is already given to you. Also, we know that if this order of variable is not given to you, then by default the order of variable is always alphabetical order. So w, x, y, z. Okay, now let's make the k map for this function. Then we can easily find the prime implicants. Okay, so this function is f this is the function. Now let's make the k map for four variable k map I need to make. So let me make it. This is the four variable k map. Let me put the most significant two variables on the column, and let me put the least significant two variables on the row. Okay, you know, this is your standard k map. 0 0 0 1 1 1 1 0. This is the standard k map. Now let's fill this k map. We already know that when we put the most significant two variables on the column and least significant variables on the row, then what will be the cell numbering? The cell numbering will be 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Yes or no? This is the cell numbering. So let's fill this k map. You can see this is a sum of minterms expression of f. So this is the minterm list, means for these cell numbers the function value is 1, and for the remaining cell numbers the function value is 0. Okay, so let's fill the k map here. 0 2 4 5. So you can see this is cell 0, so here the function value is 1. For these cell numbers the function value is 1, so you can see 0 1 2 3 4 5. Then you can see 6 7 8 9 10 11. Okay, so that's it. You can see we have filled it. Okay, so this is the K map. Now in this K map, let me label the areas also. I don't actually need to label the area because we are not finding the minimal SOP expression. We just need to find what are the prime implicants. Okay, so there is no need to label the areas. Now let's find the prime implicants. Let's find the EPI also. The question is asking for prime implicants, but we will also find the EPI. Okay, so let's see what are the PI. Our interest is in prime implicants. What is a prime implicant? This is a cube covering one cells which is as large as possible. Okay, yes or no? So remember, the PI is a cube which should only cover one cells. You should not cover any zero cell. And this should be as large as possible. This should be a maximal cube covering ones. Okay. So let's see. Do I have any cube of size 8 covering one cells? No, there is none, because actually you can easily see that this function is one only for 8 cells, only for 6 cells. So definitely we don't have any PI, any cube of size 8 covering only the one cells. Okay, do I have any PI of size 4? Is there any cube of size 4 which is covering only the one cells? So yes, there is. You can see, look at this. Okay, look at this, because I can fold the K-map horizontally, vertically. Okay, so you can see that this is a PI. This is a cube covering one cells which is as large as possible. So this is a PI. So we got one of the PI. Okay, now is there any other 4 size cube covering the one cells which is as large as possible? No, there is no other 4 size PI. So let's find the 2 size PI. Let's focus on this one. From this one point of view, this is a useless neighbor. You can see this is a useless neighbor. This is also useless neighbor. 3 neighbors are useless because these 3 neighbors are zero cells. Okay. So from this one point of view, you can see this is a useful neighbor. So what this one will do? This one will make a group with this useful neighbor. So you can see this is a PI you got. Remember, PI is a cube covering one cells which is as large as possible. So please understand that if you do like this is not a PI, because this is not as large as possible. I can make it bigger like this. Okay, so very simple. I got another PI. This is another PI. Very simple. Is there any other PI? Let's see this one cell. From this one cell point of view, useless neighbor, useless neighbor, useless neighbor. There is only one useful neighbor. So this one will try to make a cube as large as possible with the useful neighbor. So you can see this PI also I will get. This is another PI. Okay. Is there any other PI? Let's check. You can see there is no other PI. Okay. Here you can see, if tell me, if I do like this, for example, what about this? Like if I do like this, if I do like this. No, this is not a PI because this is not as large as possible. Actually, I can make it bigger like this. Okay. This pink is the PI. Okay. So that's it. So total, how many PI are there? Number of PIs. That will be total 3. We have total 3 PI. Okay, so the question is asking for total number of PI, and we got the answer, that will be 3. There are total 3 PI. Now, just for sake of complete analysis, let's also find what are the EPI. To find the EPI, first you find all the PI. We have already done it. After finding all the PI, you see what are the one cells which are covered uniquely by a PI. What are the one cells which are covered only by one PI? Okay, let's mark them. You put a star there. So you can see, look at this one cell. This is covered only by this pink PI. So this pink PI, this has become EPI also. Okay, this has become EPI also. Is this clear? I can say this pink is PI also, EPI also. Okay. Is there any other one cell which is covered uniquely by a PI? Let's see. Look at this one. This one is also covered uniquely by this blue PI. So this blue PI, this is also EPI. EPI also. Is there any other one cell which is covered uniquely by a PI? Yes, look at this one cell. This is covered only by this green PI. So this green PI will also become a EPI. Okay, let's see. Is there any other one cell which is covered uniquely by a PI? This one cell is also covered uniquely by this pink PI. So this pink PI is EPI that we have already found. Okay, so that's it. So total how many API we have? Total 3 API. Actually, every PI is API here. Okay, for this function, every PI is API. So the number of API, that is 3, number of PI is 3. And also remember, all the API, they are collectively covering all the one cells. So in this situation, when all the API collectively cover all the one cells, then we will get unique minimal SOP expression. So for this function, actually, if you write the minimal SOP, then that will be unique. Okay, to write the minimal SOP, what we will do, for all these PI, we will write the product term, then we will do the sum of those product terms. Okay, so tell me, for this pink PI, what will be the product term? Now I need to label the area. Okay, in this K-map, because I'm finding the product term for all these PI, EPI, then I need to label the area. You can see these last two column. This is the area of W, this is the area of X, this is the area of Y, and this is the area of Z. Okay, so now you can easily see for this pink PI, what will be the product term? This is in the area of W bar, this is in the area of Z bar. You can see in the area of W bar, also Z bar. What about this blue PI? What will be the product term? This is in the area of W bar, this is in the area of X, this is in the area of Y bar. Okay, what about this green? This green PI, this is in the area of X bar, this is in the area of Y, this is in the area of Z bar. Okay, that's it. Now you just do the sum of these product terms, that will be your minimal SOP expression. So the minimal SOP expression will be W bar Z bar or W bar X Y bar or X bar Y Z bar. This will be the minimal SOP expression for the given function f. So that's it. We have done the complete analysis of this question. The question was asking for number of PI, number of prime implicants, that is 3. Okay, very simple. Let's solve GATE CS 2003 question. Let me tell you, this question is actually controversial question. Actually, not controversial. There is nothing controversial here. The point is, none of the option is correct. Okay, we will see. Don't worry. We will do the complete analysis. And at the end, we will see that none of the options is correct. Okay. And I will also tell you that in this type of situation where none of the options is correct, then what you should mark. Remember, whenever there is a question in the GATE exam for which you are certain, you are 100% sure that none of the option is correct, then don't skip that question. Mark the best, or I can say the closest option that is there, that is closest to the correct answer. Okay, you find the correct answer, then what is the option that is closest to the correct answer, that you should mark. Okay, don't leave the question. If you are 100% sure that none of the option is correct, then also do not leave the question. Mark that option which is closest to the correct answer. But remember, after the GATE exam is over, you must not make wrong concept because of wrong question. After the GATE exam is over, you must say that none of the option is correct. Don't say that, okay, this option is correct. And I have seen some students, what they do, they will see that, okay, none of the option is correct. Then they will see what option is given by the GATE exam. Then they will try to change their concept according to that wrong option. They will suddenly, forcibly, they will change their concept just to match with that wrong option. That is not good. Okay, I hope you understood. So don't worry, by the end of this question, by the end of the analysis of this question, it will become clear to you that none of the option is correct here. And then in that situation, which option we should choose, that also I will tell you. Okay, so let's see. The literal count of a Boolean expression is the sum of number of times each literal appears in the expression. For example, the literal count of xy or xz bar is 4. Basically, literal count of a Boolean expression, that is basically total number of occurrence of all the literals. Okay, you can see. So the total number of all the appearances, the total number of all the occurrences of all the literals, that is basically 4. Okay. What are the minimum possible literal counts of product of sum and sum of product representations respectively of the function given by the following Karnaugh map? Karnaugh map means K map. X denotes don't care. There are some don't cares also here. What we need to do here in this question, notice, we need to find what are product of some expression and sum of product expression. But remember, we need to find minimal POS, minimal SOP, because the question is asking what are the minimum possible literal count, minimum possible literal count of POS expression, of SOP expression. So basically we need to find minimum SOP expression. Also we need to find minimum POS expression. This is what I need to find from this K map. And then in those expressions, I can calculate what is the literal count. Okay, the question is basically asking the literal count. Okay, is this clear? Let me tell you something very important, that for any Boolean function, the minimal SOP, minimal POS, they may not be unique. For any Boolean function, you can have one or more minimal SOP, you can have one or more minimal POS. But there is one thing certain, that for any Boolean function, in all the minimal SOP, the number of terms and number of literals will be same. Please understand this very carefully, that for any Boolean function, in all the minimal SOP, the number of terms and number of literals will be same. Similarly, for any Boolean function, in all the minimal POS expressions, the number of terms and number of literals will be same. Okay, so I hope you understood. So let me write this note here, that for any f, for any function f, in all minimal SOP, in all minimal SOP expressions, remember, number of terms and number of literals are same. Okay, and the same thing you can say for all minimal POS expressions also. All minimal POS expressions also, that for any Boolean function f, in all minimal POS expressions, the number of terms and number of literals will be same. Okay, and this note is actually given in this book also. And if you remember, in our lectures also we have seen this note. This is screenshot I have also put in our lectures also, where we were discussing K-map. Okay, so you can see this is not from a standard book on digital logic. Here what they are saying that if there are multiple solutions, means if there are multiple minimal expressions, then remember, read this, all minimum solutions must have same number of terms and literals. Okay, I told you this. Basically all the minimal SOP will have same number of terms, same number of literals. All the minimal POS, they will have same number of terms, same number of literals. You can see, for example, this example is also given that, let's assume for a function f, the minimal SOP expression has, let's assume, 3 terms and 7 literals. Then remember, all the minimal SOP expressions will have 3 terms, 7 literals. What it means? It means that if there is an expression for f which has 4 terms, then definitely that is not minimum. And if there is an expression for f which has 3 terms but 8 literals, then that is also not minimal. I hope you understood. Very simple point. For any function f, let's assume the minimal SOP, one of the minimal SOP expression, minimal SOP 1, let's assume this has 3 terms and let's assume 7 literals. Okay, then in that case, remember, for this function, if you write an expression which has 4 terms, then definitely that is not minimum. Okay, that is not minimal. Also remember, for this function f, if you have an expression which has 3 terms but 8 literals, then also I can say that is not minimal. Means all the minimal SOP, whatever, let's assume there are 10 minimal SOP expression for f, then all the minimal SOP expressions will have 3 terms, 7 literals. This is the point. I hope you understood. Now let's solve this question. So we need to find minimal SOP, minimal POS. This is what I need to find. That's it. Then I need to do the literal count and that will be my answer. Okay, so let's find first minimal SOP, then we will find minimal POS. Okay, so let me find minimal SOP. To find minimal SOP, what I need to do? I need to cover all the one cells with cubes as large as possible and with minimum number of cubes, correct? Okay, so let's see here. My target is to cover all the one cells, only focus on the one cells. I don't care about the don't care. Okay, remember these don't care terms are there. I don't care about the don't cares. I only want to cover all the one cells. So remember, to find minimal SOP, what I need to do? I need to cover all the one cells with cubes as large as possible with minimum number of cubes. With minimum number of maximal cubes. Or I can say that with the minimum number of cubes and every cube as large as possible. So I can say with minimum number of cubes as large as possible. Every cube as large as possible. Okay, is this clear? Very simple. So this is how I will find the minimal SOP. I will cover all the one cells. I only need to focus on the one cells with minimum number of cubes and every cube as large as possible. So let's see. These are the one cells you can see here. Total 4 one cells I have. I only care about these 4 one cells. Now, you tell me, is there any 8 size cube that I can create covering the one cells? No, 8 size cube is actually not here. Okay, now let's see. Let's focus on this one. From this one point of view, this is a useless neighbor, useless neighbor. There are 2 useful neighbors. This is a useful neighbor because this is don't care. This is also useful neighbor, this is don't care. Okay, so remember, from this one point of view, 2 useless neighbors are there and there are 2 useful neighbors. So what this one will do? This one will create a cube as large as possible with the useful neighbors. And actually you can notice that this is also don't care, so I can make this corner cube. Okay, is this clear? I hope you understood. Very simple. Because look at this one cell. For this one cell, only 2 useful neighbors are there. So what this one will do? It will create cube as large as possible with help of its neighbors. But there is one more good thing, that this corner, this is also don't care. So basically this corner cube I can create. Okay, that's it. Now you can see this one has been covered. Okay, let's see the remaining 3 ones I need to cover, right? Okay, so let's see how to cover this one. For this one, this is a useless neighbor. This is also useless neighbor. So there are 2 useful neighbors. You can see this is a useful neighbor, this is a useful neighbor. So this one, what it will do? It will try to create a cube which is as large as possible with help of useful neighbors. But remember, I cannot do this. This I cannot do because I cannot cover 0. Okay, so you can see what this one will do. This one, with the help of useful neighbors, it will create a cube as large as possible. So here, this cube you will create because you only need to cover all the one cells with minimum number of cubes. I don't care about the don't care. Okay, so you can see these 2 ones are also covered. Now remember, I need to cover this one also. To cover this one, can I create a cube of size 4? For this one, you can see this is a useless neighbor, this is a useless neighbor. 2 neighbors are useless. There are 2 useful neighbors. With help of these 2 useful neighbors, I will create cube as large as possible. Now you can see, can I create this cube? No, I cannot, because here you are covering 0, you should not cover 0. So I need to create 2 size cube. Either I can create this one or I can create this one. Whatever you create, that is fine. Okay, so basically you can see either I can create this one or I can create this one. Okay, I hope you understood this. So that's it. Basically, there will be 2 minimal SOP expression, but don't worry, all the minimal SOP expressions will have same number of terms, same number of literals. Okay, so you can see for this function, there are 2 minimal SOP. For this function f, this function f has this function f has 2 minimal SOP, has 2 minimal SOP expressions. Okay, very easy. So what are those two minimal SOP expressions? Minimal SOP1, minimal SOP2. Remember, both the minimal SOP expressions will have same number of terms, same number of literals. Okay, so let's see what this first minimal SOP will be. You can see I will write the product term for all these cubes. First, let me label the areas. Okay, you can see this is the area Z, this is the area W, this is the area X, and you can see this is the area Y. Correct? Okay. Now you can see for this green, cube, what will be the product term? This is in the area of Z bar, X, also in the area of W bar. Okay, so you can see by default, what is the order of the variables? By default, the order of the variables is actually alphabetical order. Here in this question, the order of the variables is not given. Notice the order of the variables is not given. So by default, the order of the variables is actually alphabetical order. Means by default, the order of the variable will be W, X, Y, Z. This will be the by default order of the variables. Okay, this is by default. But something interesting you notice here, that here we are writing ZW. Okay, so actually it doesn't matter. You don't have to worry. There is nothing ambiguous here because ZW, and you can see that in these last two columns have Z equal to 1. So this will become the area of Z. You can see this will become the area of Z because the last two columns have Z equal to 1. Also, you can notice the middle two columns have W equal to 1. So the middle two column will become the area of W. The last two row will become the area of X, and the middle two row will become the area of Y. Okay, everything is very clear because the numbering here, the standard K map is there. Okay, so everything, there is nothing ambiguous basically, I can say. Okay, so let's see the minimal SOP1, minimal SOP2. What will be the product term for this green cube? This is in the area of Z bar, X, and W bar. Okay, I can say W bar, X, and Z bar. Very simple. Okay, what about this blue? This blue cube, what will be the product term for this blue cube? This is in the area of Z bar, X bar, and W. Okay, so you can see W, X bar, Z bar. And what about this corner pink cube? This is in the area of Y bar, W bar. Okay, W bar, Y bar. So finally, the minimal SOP expression, that will be W bar, Y bar, or W X bar, Z bar, or W bar, X, Z bar. You can stop here. You don't have to find the remaining minimal SOP because I told you that all the minimal SOP will have same number of terms, same number of literals. So you can easily see that here I have 3 terms, and total how many literals? 3, 3, 2, 8 literals. 8 literals. Okay, so the same thing will happen if you write the minimal SOP2. Okay, then also the same thing will happen. In the minimal SOP2, you can see this blue. What is this? What is the product term for this blue cube? You can see that is W X bar Z bar. W X bar Z bar, because okay, let me label the area. So you can see this is the Z, this is the W, this is the X, this is the Y. Okay, so you can see this blue one has W. This is in the area of W, X bar, and Z bar. Okay, what about this pink? We have already seen this is W bar, Y bar. Okay, you can see W bar, Y bar. Okay, and what about this green? This green, this is in the area of X. This is in the area of Z bar. This in the area of Y. Okay, so that's it. Now you can easily see what will be the minimal SOP. That will be W bar, Y bar, or W X bar, Z bar, or X, Y, Z bar. This is another minimal SOP. Here also you can see that there are 3 terms and there are 3, 3, 2. There are 8 literals. Okay, and remember that F has only 2 minimal SOP. This function F has exactly 2 minimal SOP. Not more than that, not less than that. The number of minimal SOP is only 2. So finally, I can say that minimal SOP has 8 literals. Okay, yes or no? I can say minimal SOP. We have already found that it has 8 literals. Now let's see. Do I have any option where the minimal SOP has 8 literals? Notice one thing. This number of literals in minimal SOP, that should be your second component. Okay, that is second component. You can see in the second component, we don't have 8. That is the reason I am saying that none of the option is correct. Please understand that for this function, there are only 2 minimal SOP. Both the minimal SOP have 3 terms, 8 literals. So that is the reason here, none of the option is correct. I have seen some students, what they do, just try to, they by force, they try to match with the wrong option. So they change their concept. Please don't change your concept. Don't modify your concept because of wrong questions, wrong options. Okay, please understand. Concept should be correct. Follow always the correct concept. Don't worry about the wrong answer. Sometimes even the IIT professor, they can also miss out. In this question, they have missed out. They have not given any correct option. Because of wrong question, because of the wrong options, don't change your concepts. Stick to correct concepts. Okay. Now let's see what about minimal POS. Now let's focus on minimal POS. Find minimal POS. To find minimal POS, what I will do? I will cover all the zero cells. I only care about the zero cells. I don't care about don't cares. I don't care about don't care terms. Okay, so remember, I only want to cover the zero cells with minimum number of cubes. With minimum number of cubes. And every cube as large as possible. Okay, so that's it, very easy. So this is how you can find the minimal POS. Just cover all the zero cells with minimum number of cubes, every cube as large as possible. Okay, and remember, I don't care about the don't cares. If they are helpful, I will take them. If they are not helpful, I will not take them. That's it. Okay, so very simple. Here, now what are the zero cells? You can see these are the zero cells. Total, how many zero cells we have? Total 6 zero cells we have. Okay, so let's see here. To cover these zero cells, these are the zero cells. You can see to cover these zero cells, I will use minimum number of cubes and every cube as large as possible. So you can see here, just focus, for example, focus on these two zeros. I can create this cube, correct? Yes or no? I can create this cube, I can create. Okay, this is a 4 size cube. Remember, there is no 8 size cube here. Because there is no 8 size cube, so the maximum size cube I can create covering zeros or don't cares, that will be size 4. So you can see this size 4 cube I can create. Now these two zeros I have covered. Okay, what about these two zeros? You can see I can make this cube or I can make this cube. Yes or no? You can do any of them, no problem. Okay, so remember one thing, that either I can use this cube or I can use this cube. Okay, but please understand that for these zeros, if you look at these zeros, I will create this cube because I cannot create this cube because it is covering 1. I cannot create this cube because it is also covering 1. Okay, so I cannot create this cube because you can see this is covering 1. So please understand that for these two zero, it is mandatory that I create this cube. But remember, for these two zero, I can create either this cube or I can create this cube. Okay, so very simple. So either this situation you will get or this situation you will get. Okay, now let's see. Did I cover all the zeros? I only want to cover all the zero cells. I don't care about the don't care terms. So here, which zero are remaining? You can see this zero is remaining. For this zero, you can see I will create this cube. This is a size 4 cube. Yes or no? Because remember, from this zero point of view, this is a useless neighbor. This is a useless neighbor. Two neighbors are useless. There are two useful neighbors. With help of these two useful neighbors, I will create a cube as large as possible, covering zeros or don't cares. So you can see this cube I will create. Okay. So you can see here also, you can see this cube I will create. Okay. What else? Did I cover all the zeros? Here, this zero I did not cover. From this zero point of view, this is a useless neighbor, useless neighbor. So there are two useful neighbors. This is a useful neighbor. This is a useful neighbor. With help of these two useful neighbors, if I try to create this cube, then I cannot do that because here this one cell we are covering. So remember, to cover this zero, I need two size cube. Okay. I need two size cube to cover this zero. I need two size cube. Here understand one thing, that only this zero is remaining. All the other zeros are already covered. Only this zero is remaining. So either I can do this or I can do this. Both are perfectly fine. Okay, so remember, either I can do this one or I can do this one. Okay, both are perfectly fine. So you can see here I got minimal POS 1. This will give me minimal POS 1. This will give me minimal POS 2. Okay, now let's see what other minimal POS I will get. Here you can see this zero I did not cover. So either I will make this cube or I will make this cube. Okay, so again you can see that I got this minimal POS 3 and I got this minimal POS 4. Okay, total how many minimal POS I got? Total 4 minimal POS I got. But remember, all the minimal POS will have same number of terms, same number of literals. So you don't have to find all the minimal POS. You just find any one minimal POS and you count how many terms, how many literals it has. That will be your answer. Very simple. For this minimal POS1, you can write the expression. You don't even have to write the expression actually. You already know that we have total 4 cubes. Okay, and remember, when we have a cube of size 2, then one variable will be eliminated. So this actually will give me 3 literals. Here I will get 3 literals. Okay, I am saying that you don't have to write the minimal POS expression, because to write the minimal POS expression for all these cubes, you will write the sum term. Okay, I am saying that for this cube, this is a size 2 cube. If I write a sum term, then one variable will be eliminated. Okay, and three variables will be present. So I can say 3 literals it will give me. Here you can see this is a size 4 cube. So when I write the sum term for this, then that will contain 2 literals. Okay, you can see this is also size 4 cube. This will also contain, the sum term for this will contain 2 literals. And you can see this is also size 4 cube. If I write the sum term for this cube, then that will also contain 2 literals. Okay, so I can say total number of literals in this minimal POS, the number of total number of literals, I can say total number of literals, that actually will be equal to 2 plus 2 plus 2 plus 3. So that will be 9. Okay, so you don't even have to write the expression. Very easy point. Okay, if you want, you can write, there is no problem. Okay, you can write. Let me write it just for sake of complete analysis. Let me write, for example, for this cube, what will be the sum term? I need to write the sum term because I'm finding the minimal POS expression. First, let me label the areas. Okay, in this K map, let me label the areas from the sum term point of view, or I can say from POS point of view. So you can see that this is the area Z bar. This is the area Z bar. You can see this is the area W bar. You can see this is the area X bar, and you can see this is the area Y bar. Okay, is this clear? I'm labeling the areas from the minimal POS point of view. Okay, so now you can write the sum term. So you can see for this blue cube, for this cube basically, for this cube you can see what will be the sum term. This is in the area of Z, X, W. Okay, so this is in the area of W, X, Z. So this will be the sum term. Next, what about this pink? For this pink cube, what will be the sum term? This is in the area of w bar x bar. Okay, so this is in the area of w bar x bar. So this will be the sum term. Next, you can see for this one, what is the sum term? The sum term will be, you can see, this is in the area of z bar y bar. Okay, so this is in the area of z bar y bar. So this will be the sum term. And you can see for this orange, what will be the sum term? The sum term will be, you can see, this is in the area of z bar, this is in the area of w bar. Okay, so you can see this will be w bar or z bar. That's it. Now what you can do, you can do the product of all these sum terms. Okay, that will be your answer. So minimal POS, this minimal POS 1, so what that will be, you can write it now. So that will be w or x or z and w bar or x bar and y bar or z bar and w bar or z bar. Okay, that's it. This is your minimal POS 1. Okay, minimal POS 1. That's it. So finally, this minimal POS 1, this will have total four terms and 9 literals. Okay, and remember, if you write this minimal POS 2, this will also have 4 terms, 9 literals. This minimal POS 3, this will also have 4 terms, 9 literals. And this minimal POS 4, this will also have 4 terms, 9 literals. You can write these, that is your homework. Okay, so homework is that you write this minimal POS 4. I've already made the cubes. You write this minimal POS 3. I've already made the cubes. You write the minimal POS 2. I've already made the cubes. Okay. Actually, you can see here, without writing the minimal POS 2, you can see how many literals will be there, because you can see this is the cube of size 2. So when you write the sum term for this cube, then one variable will be eliminated. So 3 literals it will give me. Okay. This is size 4 cube. This is size 4 cube. And this is also size 4 cube. They will give me 2 literals. Okay. So you can see this will give me 2 literals. This will give me 2 literals in the sum term. Okay. And this will also give me 2 literals. So total how many literals I will get? 2 plus 2 plus 2 plus 3. So you can see 9. Total 9 literals I will get. This is what I'm saying. Okay. So that's it. Finally, what will be the answer for this question? So I can say that minimal POS will have total 9 literals. Okay. So the answer will be 9,8. The correct answer. The correct answer will be 9,8. This is the correct answer. But actually, in this question, none of the option is correct. So what is the closest answer that is there? Can you tell me? What is the closest answer? The correct answer is 9,8. If the same question comes next year, and if one of the option is 9,8, that will be the answer. If this question comes as NAT, then also this 9,8, this will be the answer. But none of the option is correct. What is the closest option? The closest option, that is basically 9, 10. Yes or no? This is the closest option, but this is not correct. Please understand, this is closest but not correct. This is closest to correct, but this is actually not correct. This is wrong, but this is closest to correct. So you should mark it. Now some students might be thinking, sir, in this situation, if I'm 100% sure that none of the option is correct, then should I skip this question? Should I move to the next question in the GATE exam in those 3 hours? The answer is no. Please don't skip the question. Mark the closest to correct. That's it. Here the closest to correct, that is option C. So you mark it. Okay, but remember, because of this wrong option, because of this wrong question, don't affect your concepts. Is this clear? Here you can easily see for this function one very interesting thing you notice. Interesting point. Okay, for this function that is given to you for previous function, for previous function, for previous function, you can easily notice that. Let's see minimal SOP, minimal POS. Minimal SOP are how many? Minimal POS how many? Notice we have two minimal SOP. Number of minimal SOP 2. Number of minimal SOP expressions. What that is? That is 2. And each minimal SOP has how many terms? How many literal? Each minimal SOP has how many terms? How many literals? You can see each minimal SOP has 3 terms, 8 literals. 3 product terms, 8 literals. Okay. Look at minimal POS expressions. You can see the number of minimal POS expressions. Those were 4. Total minimal POS expressions were 4. Also notice each minimal POS has 4 terms, 9 literals. This is what I told you, yes or no? That for any function, all the minimal SOP will have same number of terms, same number of literals, and also for any function, all the minimal POS will have same number of terms, same number of literals. Please understand something very interesting. That is, notice number of minimal SOP is 2, but number of minimal POS is 4. So remember, number of minimal SOP, is that always equal to number of minimal POS? No. Number of minimal SOP is 2, number of minimal POS is 4. Also notice, in the minimal SOP you have 3 terms, 8 literals. In the minimal POS you have 4 terms, 9 literals. So please understand, there is no relationship between minimal POS, minimal SOP. Both represent the same function, but you can have different number of minimal SOP, minimal POS for the same function. You can have different number of terms in the minimal SOP, minimal POS for the same function. You can have different number of literals in minimal SOP, minimal POS for the same function. Overall, this question is very interesting. All these interesting points you can observe, but this is a sad thing that this question has no correct option. Okay, actually, let me tell you, the question maker was thinking about what? See, why the question maker did not give you option 9,8? What is the reason? 9 is fine, means the question maker has found the correct minimal POS expression. That is fine. Okay, but the question maker, by mistake, the question maker did not count, or I can say did not find the correct minimal SOP. Okay, let me tell you where the mistake happened. So here, when the question maker was finding minimal SOP, what the question maker did, let me tell you. While finding the minimal SOP, the question maker was thinking, okay, let's cover all the 1 cells. But the question maker, to cover all the 1 cells, he created this big cube. Okay, because I have seen many students, what they think, okay, that directly create the biggest cube that is there. Remember, the question is asking for minimal SOP. The question is not asking for prime implicant EPI. Yes, this is a PI, no doubt. This 4 size cube, this is prime implicant, but this will not be a part of minimal SOP. What is the reason? Because I want to cover all the 1 cells. I don't care about the don't cares. So actually, to cover this 1 cell, I will take this. Okay, so what the question maker did, let me tell you what the mistake the question maker did. The question maker created this big cube first of all. Okay, now this one has been covered. Now to cover the remaining ones, to cover this corner one, this cube the question maker created. Okay, this cube the question maker created. What other cube the question maker created? Still, two ones are remaining. This one, they are remaining. So what the question maker did? To cover this one, either the question maker created this cube or created this cube. Any of them is fine. Okay. So let's assume the question maker created, let's assume this cube. Now, to cover this one, the question maker created maybe this cube or maybe this cube. Okay. Maybe this cube or maybe that cube. The mistake, did you notice here? Did you notice the mistake? Because of this yellow, let me use the yellow, or let me use this orange color. Did you notice the mistake here? What the question maker did? The mistake the question maker did is this blue, this is covering these don't cares and this one also, but this one is already covered by this orange. So you don't need this blue. This is actually not needed. Why this is not needed? This is not needed because this one is already covered by orange one. Yes or no? So remember, this blue is not needed because the one cell. Okay, let me write the reason here. So this is not needed because the one cell that it covers, the one cell that it covers is covered by orange cube already. Okay, yes or no? So this is what I'm saying, that in the minimal SOP, you won't have this blue cube. Won't have blue cube. Okay, but the question maker did this mistake, that the question maker created this blue cube. Now, because of this blue cube, what will happen? Notice, the question maker created the blue cube by mistake. Okay, overlooked mistake, basically by mistake, maybe overlooked. Okay, so you can see what, because of this blue cube, what will happen now? You can notice the blue cube actually will give you how many literals? This is a 4 size cube, so this will give you 2 literals. Okay, this will give you 2 literals. This corner cube, this is a 4 size cube, this will give you 2 literals. Correct? Okay, next you can see this orange will give you 3 literals, because this is a 2 size cube, this will give you 3 literals. And this green will give you 3 literals, because this is a size 2 cube. Total how many literals I got? 3 plus 3 plus 2 plus 2, that will be 10. That is how the question maker got this 10. And that is how the question maker thought, okay, the answer will be option C. Okay, so this was a mistake the question maker has done. I hope you understood the complete analysis of this gate question. The important thing is that in this gate question, I have seen some students, what they are doing, they are changing their concept because of this wrong question. Please don't do that. You can see this is a note I have written under this question on the Gate Overflow website. On the Gate Overflow website, under this Gate 2003 question, this is the comment that I have written. You can just read it. You can see, to all the students, I am saying that for this Gate 2003 question, simple conclusion is that the answer will be 9,8. That's it. The question maker missed it. The question maker made a mistake, gave wrong options, and some students are forcibly trying to match with that wrong option. But in future gate question, the question maker won't miss it. So always follow the correct concept. Okay, this is the point. I hope you understood. So that's enough for this session. In this session, we have done a lot of gate CS PYQs with complete analysis. Some questions we have solved with multiple methods. Okay, I hope you understood every question in this session. I hope this session was helpful. Please let me know your feedback in the comments. Please like this session and please put a comment and let me know your feedback. Okay. Okay. Thank you, everyone.